All right. Good morning, guys. How are you?
Alright.
Good. Good. Morning, Orlando. Morning. What about the rest of you? Are you awake? Peter K, you awake? Kimani, are you
Yes,
awake?
I'm here.
All right. Good. 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 Everton, wake up. Jesus.
Sir, you sound like you're still asleep,
Oh
sir.
no. I was up from.
I
I was
don't
up.
believe you. I don't
No,
believe you.
well, I can show,
That voice, they sound like,
and I will tell you why.
Lord
Uh,
God, we have
no, no,
class, more sleep.
no, and quite the contrary. I went out to you about that one before. No man, I have some chemistry paper that have been nagging. I've marked off all my math papers, and I have and funny enough, my chemistry paper was the first exam that went on the 1st of June. But there was a problem with the paper, and I said, you know what, let me delay it and just mark the other papers. And me I see good last night, and Father God said, get up. And I get up and I say, okay, it's time for me to go and watch a couple TikTok. And say, oh no, go mark the people, get them paper. And I got up and I started until 4:30. I was up marking. I said, no, let me go lie down. And as soon as I go lay down, I have this violent cough. So that's how the voice sound like that. And I get up earlier to log on, and I still have that sort of tickling feel in the back of my throat. But no man, no, let me just explain something to you. There are two of you already in the class that would have heard about this, and and I just need to say it because I um, it's a shortened semester, and even more shortened because um, this is really week 4, so technically only it's 3 weeks. So we have to be creative now in finding those 3 classes to make up. That's number one. And number two, when my grades were submitted, I literally spoke to Mrs. Campbell and said, Mrs. Campbell, um, you know, we have to have a fast track class for the calculus too, because I know that there are some of you having interacted with you in the past. I know that this is it. This is a semester that you must leave Excelsior Community College. And the question came, are you available? And I said, I could be available. And I watched the emails go from Mrs. Campbell's office to the front office and back and forth. And when I saw the approval given, um, it was run about the same time that I finished writing your mid-semester exam and finished writing the final exam and submitting the final exam. So your final exam was already submitted to exams because we are already late. So I don't have that to worry about. Your mid-semester is already prepared. Don't have that to worry about. But even at the expense of not starting now, but just getting some ground rules out. Uh, and I want us to have this agreement. Now, yes, the truth of the matter is, having gone to bed at, well, not even bed, I call it, but lay down 4:30 this morning, I could have done well with still be lying down now. But it is a sacrifice that I'm making for you guys because I know where some of you are. I know for a fact at least two of you are finalizing. And I would have taught in the past 1, 2, 3, 4, 5, Rockstone. All of you. I would have interacted with at some point in time. But I know 1, 2, 3, 4, 5. I know 6 of you for sure should be finishing off based on when I taught you. If everything went well, I know 6 of you should be finishing off. But there are 2 students in particular that I know who I confirm that this is it for them. This is a last chance for them to finish off this stuff. Why am I saying all of this? I don't want no foolishness from on here. I don't want no foolishness from you guys. Your Edicus is up. Your assessments are also up, and I want you to go through your tutorials.
Sir, can we bypass Edicus off, sir?
No, you can't.
And just do paper, sir. Edicus off stressing, you know, sir.
Everton, hear me out. Matter of fact, when I finish Everton, you can talk to me because I have some very useful suggestions. When I meet with you on a Saturday morning from 8 o'clock to 12 o'clock, that is not sufficient interaction. What I recognize is that some students, and let your conscience be your guide, are outsourcing Educasolve for their friends to do for them. I know it. You know why I know it? I don't understand how I'm seeing those beautiful grades on Edico, but when I'm marking like the mid-semester, it is not adding up. The 100% and the 80% and the 90%, not adding up with the mid-semester, and worse yet, not adding up with the final exam. So I know what is happening. And I'm going to say to you guys, if you continue that for this semester, or put it this way, if you plan to continue that for this semester, let me know right about now so that I can just finish off the class today and then say to Mrs. Campbell, find another lecture, because I'm not going to be prepared to do that. So far, I'm seeing 10 of you in the class. I know that there are other students who should be joining. I'm not sure if they are available for the summer, but based on what I'm seeing on the grade sheets, I know that there are other additional students. If you plan to, and one more just came, if you plan to, well, the same person, if you plan to continue outsourcing, and it's not all of the outsourcing, but I have seen the ones who are outsourcing, and I know, and I won't tell you how it is that I know, but the system tells me, and I'm no computer person, but the computer persons tell me how to check, and I know. So let me not even pretend any further that I don't know what is happening. Hear me out. If you sit yourself down and you take your time to learn the concepts in answering those questions on the platform, I guarantee you it will make a difference with the final grade. I guarantee you it will make a difference with the final grade. I saw something happen. With some uploaded. Let me not. But I saw some things happen with Calculus 2, right? And you won't know if it is Calculus 2 day or Calculus 2 evening. But let me say to you, something happened with another course, similar to what happened in Calculus 2. But let me not use Calculus 2 since I'm in a Calculus 2 class. We can't chat it in front of the face. But in another course I was teaching, I had to say to my assistant, go up on the platform, download a paper here for me, and look on it. And because I don't want to give away anything, because we have our ways to double check to see what is happening when we give final assessments. And I didn't say anything to my assistant. And my assistant said, but Shand, You know, see, I said, me see. And that's why I ask you to do it. Now, I'm going to say to you, honesty is the best policy. And I'm not speaking to everyone, but I just need for it to be out there. I want it to be out there because I want you guys to know that we know. It's not just with the math courses. It also happens with other courses. And this is why a decision was taken to put on the face-to-face classes, the exams, because of the heavy levels of collaboration taking place. Suffice it to say, that decision was rescinded. But students, you cannot continue doing it like this. It's not good. If you have a challenge with the math, sit down with the maths and learn the concepts. You have to learn the stuff. If you outsource your work to be done by somebody else, it's not going to benefit you. So I want you guys to promise me this semester, this very shortened semester, where I know I have to run like boat, but be very mindful that I have students who genuinely have an issue, not only with calculus 2, but with math on a whole, and will need that level of patience. I'm very cognizant of that. But you have to promise me that there's going to be honesty in my class. I am disappointed. I'm very disappointed. I'm very disappointed. Very disappointed. I'm marking papers and I'm saying, but where did I see this stupidness before? He said, no, man, my mark that stupidness already, man. Sure, let me see it. And when I stop my marking and go through the other people, I said, oh, I saw it come from. And when you look, you see the same stupidness, not with one student, but with a cluster of friends. And I know the cluster of friends. It's not good. I'm going to tell you straight up. For me, honesty is the best policy. If never fail, of course, more fail to myself. Me can't cheat and fail. All right? So I just want to put it out there because I don't want anybody to take me for a kunumono that I don't know what is going on. Me know what I'm going. And I'm asking you not to repeat it. I'm asking you not to repeat it. We're going to come to class on a Saturday morning. Fortunately, they have extended the semester until up to the 30th of August, if I'm not mistaken. All right, and we're going to maximize. I know we have to be very creative to find some additional time because we would have missed 3 weeks, and already it is a very shortened semester. So, if we have that understanding, we can put the gear shift in drive, and then we can go. But before I do that, I'm going to give anyone, seeing one or two of you that I'm seeing two of you that I've not interacted with in the past or before. So I'm going to give you an opportunity. Anybody, if you have any questions of me, as we are laying the ground rules, anything you want to ask me, anything you want to say, any clarification. I won't even go through the do's and the don'ts because, as I said before, most of you I would have taught in the past, so you know my temperament. So the two that I'm seeing that I don't recall teaching, they will catch on easily. So, your turn. What do you have to say to me? All right. So you have nothing to say. I'm not going to belabor the point. Oh, there is one other thing before I move. So For those persons coming from Mr. Russell's class, don't know how Mr. Russell conducted his class, but for sure, when I'm having my class, I expect people to have a conversation with me. When I ask a question, I don't expect to be answering my own question. If that's the case, I can go stand up in my bathroom and I can look in my mirror and I can ask myself, what is the differential of e to the x? And I can look at me and I can answer e to the x. And I can ask my question again, what is the integral of e to the x? And I can look at myself in the mirror and I can say e to the x. So I can have that sort of conversation with myself. So I don't need to do it in front of you guys. So when I answer a question, I expect you to unmute and answer me. That's the minimum that we can have. That's a minimum that we can have. There are some of you who, if I don't call on you, you stay silent. Yes, sir, I'm understanding, and me know better. I'm teaching long time. I really want us to have an interactive class, and we can have an interactive class. I know there are people here who can be very interactive. So I am hoping, and waiting with bated breath that this is going to be an interactive Saturday morning so that you can ask me your questions, so that persons who are not so clear on the area can listen to your questions and you can learn from them. So, I ask one question and everybody's silent. Best believe that I'll go silent. And on a Saturday morning, when sleep is the order of the day, when you unmute to talk, I may very be sleeping. What's the point I'm making? You don't want the foolishness. I want you to be very hungry for this, so that together we can churn up a little food, and we can deal with it. All right. Okay. So so since there are no questions to ask of me, I would love to do. I don't know why this thing is. All right. Let me just try that. Lord, I need to come back to these papers. Oh, the life of a teacher. All right, let me try it. All right, so we're going to be moving into some applications of differentiation. Oh, sorry. As I said at I didn't 2 limits. Oh, come on. I didn't do the
Sir, I have a request, sir.
Go ahead,
I have a request.
Go ahead.
Drop the past paper when I just feel and make we go through it. I look on where it went wrong. Please.
I have no problem doing that. Yeah, I have no problem doing that, but can you?
Well, you have to start back from scratch, But I really want to see where me starting off back from scratch applies where I went wrong in the paper.
Yeah, but I'm going to tell you something that normally happens to me, and I don't want to put other students through it. I remember when I was studying, very enthusiastic, and first class, I may say, "What? Me like we're going." Me run go by past paper. Then the days that you just go to the library and photocopy past papers with the photocopy card, and I will sit down over the papers and can't do a question, and get very depressed. So I don't want to touch the past papers yet. I will do it because that's part of my plan. I plan to do it, but I don't want to touch the past paper. I just said Kelly, because I don't want people to say Lord Jesus, and it brings back the trauma of you feel in that said paper. So what I'm going to do is just to go through some of these here. What I did and what I normally do is when I go through a particular topic, I would then jump into the past papers, and then jump into the past papers, we work the questions so we can get the past paper feel as we go along. But best believe that I will be working those those questions that would have brought you back to hear this annoying voice. Trust me, I will definitely do that. All right. So what we're going to be looking at is some. I want to do a little review, and a little review of what we did in calculus one, and even I could even say calculus two too, because you're required to do a lot of differentiation.
Morning, sir. Mr. Shannon, what's the topic again?
Who's this? Kimani?
No, sir, Forbes.
This is Romy. Okay, all right. I know
Mhm.
it would have been one of two. Um, Applications of differentiation. So
Oh,
that's the
okay.
first unit.
All right, thanks.
No problem, Papa. Yeah, so applications of differentiation. And the applications of differentiation would consist of a lot of little areas. We're talking about Newton-Raphson, we're talking about McLaren series, we're talking about then little fufu, easy something there, right? But when you're talking about Newton-Raphson, you know that you have to differentiate. Mark, even Newton-Raphson causes us to differentiate just once, right? And then we're going to use that level of approximation to decipher what is to come. But for McLaren series, we have to differentiate multiple times. So, and we have to find multiple differentiations. So we're going to find the first derivative, then the second derivative, then the third derivative, then the fourth derivative, and it depends on how far them want you to go. We may even have to find the fifth or the sixth derivative. So you need to know how to do um, not only first order differentiation, but you also need to know to do second and third and fourth order differentiation, right? So, and of course, we're going to be doing some approximation, some little, as I said before, really not difficult. So let me see how far I can get into unit one. If I can finish off unit one today, and I will congratulate you. I'm going to congratulate you for taking up the offer. I know some of you don't have a choice, but I congratulate you for taking up the offer this point, because at least you know that even though you failed the course, there's something that will still be left fresh in your mind, and I'm hoping that this sort of freshness is here. Yeah. So give me half a second, please. My heart overflows. All right, I'm going to ask a quick question, and I want a simplified answer for this. I need help. When I why is it that when I open a document, it opens immediately into read only when I am the original author of the document? Anybody can give me a quick response? And how I can prevent me opening a document and it goes to read only? It's kind of annoying me. That's why I'm asking.
Because sometimes what happens is that sometimes person might be depressing the keyboard accidentally or stuff, and they edit documents that should not be edited. And then when they fix it, undo and resave it, it is then marked, and then the document is marked as the integrity of the document has changed. So what this happens by default, you get read-only access, and then you decide if you want to change.
So let me ask a question now, Everton. Even if I'm the author of the document?
Yes. Yes.
So how do I prevent, what do I do?
What you talking about? Excel?
No man, Word.
Word, yeah man. Same thing. Same
If
thing.
you alter the document, you know, so you should be able to change the settings, you know.
Yeah, but then
And
when you change the
sometimes
settings, it affects, is a global setting, sir. So it's going to affect every document that you
every
open.
document, yeah.
So that's the premise.
So hold on there now, explain this to me. So the global, and this is one of the other things here, guys. I'm not the author of all knowledge here, so I often come to my students for solutions. So you see, when you talk about the global settings, so I'm trying to open up a document here now that contains some notes on applications of differentiation, as Romain just asked a while ago. And it keeps opening as Word only. And I did it like about 3 times. So if I change the setting, it will affect all the other documents I have on the system?
In the sense that all that, like if you download a document from the internet by default, if you change the setting, what's going to happen is that document will open up in write mode, read write. So if something does accidentally get changed, say you have that document and someone sends the document to you with a protection macro on it that can tell what field and what has been changed and whatever, and you accidentally change it, they can tell, and then the integrity of the document to be thrown out. So by default, they leave it because everything is being moved online or whatever. They're trying to integrate all of what they need into the application that persons normally use. So you're going to have that. You can change it, sir. You can. But you know.
All right. My final question to you, all of you, is what I normally do in order to get rid of the word. I mean, I know I can use the word only and then resave it, but it's just the resaving that gets to me. What I normally do for the document is just close it and just open it multiple times, and then the read only will come out. But like I'm listening to the period you speak to me, and like no, I don't know why it is that I decided to close it, because it is taking a while now. But anyway, I know when it takes this long, it's gonna come out as read only. So I guess, all right, guess what? It's computers.
No, sir. Are these documents that you are passing on the internet are of any sort?
So I'm passing on to the internet, meaning
yes,
like
you are
emailing,
sending it, emailing it, anything of the sort.
Yeah, man. I email it to myself, and then I send it and say, okay. So I just open it a while ago, and the read only is off now. So that's what I normally do, is whenever I open it and it comes on, the read only comes on, I just close the document and just open it as many times for it to come off. So it's now off. But yes, so what I do is, well, you know this. What I do is to, do some electronic notation of the things that I would have done. So for example, like when we're doing a past paper, I will go and I literally type out the past paper question, not copy. I will literally type out the past paper question, and I'll do the solution, because I would want you to see what is happening. So I keep these stuff. So I will email it to myself and then send it off to you guys as a PDF document. So yes, I do email the documents quite a bit.
Okay, well, I was talking about the word version of the document.
Yeah, that's what I'm saying. So I do email the Word version to myself, though, not to anybody else, but to myself.
Okay.
Yeah.
Okay, I get you. Yeah. I get you.
All right. So, so you see that I would have started my screen sharing, and I just want us to.
Sir, not seeing the screen, sir.
Not see the screen. Anybody see my screen?
I'm
seeing
just
a blank
seeing the
screen.
white.
Yeah, that's seeing a blank. Stop sharing. Stop sharing and share again, sir.
No, he's sharing. He
I'm
has
sharing
written
enough.
He has not written anything.
I haven't written anything yet, man.
Oh, is that okay? It's like a whiteboard. Okay. Okay, understood.
You see me now?
Yeah.
Sir, give me 2 seconds, sir. I'll be right.
Did you realize it was a whiteboard, sir?
Yeah, man, it's a whiteboard, man. you know, people like Everton tell me, say, must step up my game. So, me step up my game and, you know, invest in my things then. All right.
All right.
All right. So, let me just get this off. All right. So it's really a recall that I'm going to be looking at. And me talking about my whiteboard, I think I may need to change.
Sir, morning, sir.
Morning, one.
Sir, no bother with them writing this, sir.
It's not me, you know, it's Shanice. Let's leave in Jesus' name, Shanice. It's too early in the semester for your trouble, man. No, man, the tip, I just said a while ago that I think the tip of this thing, I may need to change. And I forgot to look for the tip. It's not me. After a while, the pen tip wears down, so it's not as smooth as before. All right. Lord, let this thing work out just for me. Let's see. In Jesus' name. All right. So we're going to recall. We're going to recall. R-E-C-A-L-L. All right. So we're going to recall. Now, if I gave you something like this, say y is equals to 4x squared plus 3x minus 5. And I ask you to find dy by dx. Work with me. How do I find dy by dx? How do I differentiate this function with respect to x? What do I write?
If x.
That's what Peter gave. What that Peter gave works a while ago, saying that you don't have a clue?
Yes, sir. I remember how to do it, sir.
Peter gave. I want you to leave. I don't want to Peter gave. What do you mean enough for the Peter? Sure. All right. Let's.
Sir, it will be 8x plus 3.
Very good chance. It will be 8x plus 3. All right. So no problem, Peter gave. We will, and that's why you're here. I'll go through this stuff with you. All right. So yes. So very good. So this is going to be 8x plus 3. All right. So remember. If you're given y to be equals to x to the n, recall that dy by dx is going to be, taking this n and multiply it by the number in front of that and then subtract 1 from the power, right? So if y is equals to x to the n, what I'm going to be doing is to take my power.
So I just remember.
Very good. Take my power and multiply it in front of my variable, and then I'm going to reduce it by 1. So again, let us look at an example. If I gave you y to be equals to, say, 7x cubed, what I'm doing here, I'm taking this 3 to multiply by 7, then I'm going to reduce it by 1. Let us try that. So dy by dx is going to be equals to 3 times 7 is 21. X to the 3 minus 1 to the second power. And that will be our answer. Everybody remembers? No?
Yes, sir.
Good.
Coming back.
Coming back. Very good. And watch me. Similarly, if I gave you y to be equals to 2x, remember that is x raised to the first power. We never normally write to the first power, but just believe and trust me that there's a 1 right there, right? Same difference. 1 times 2 is 2. So dy by dx is going to be equals to 2. And when I subtract 1 from the power, I'm going to have 0. So I can put x to the 0. But remember, anything raised to the power 0 is 1. So I'm just going to have 2 for my answer. All right? And let us look at the example. Let us look at the example where
Sorry, just I'll come back, sir. Sorry.
No, so we're just doing some revision on the differentiation. So you can just follow up because I'm going to be doing many more of these just to get you guys warmed up. So let's just look at this one here. Y is equals to, say, for example, 8, whole number 8. Whole number 8. Watch this trick. There, anything raised to the power 0, like right here, so, is 1. So just remember, when you get a whole number 8, that is going to be 8x to the 0. But we don't normally write it because anything raised to the power 0 is 1. So just leave it alone. We're not going to write it. But when we're doing the differentiation, best believe again that we're going to have this 8 times the 0 times the 8. 0 times 8 is going to be equals to
1.
If I clap it, if I turn your 1 today, it's going to be equals to 0. So this is going to be 0, and it don't really make sense. You say x to the 0 minus 1 because
X and 0,
x to the 0 minus 1 times 0 is still 0, don't it? Yeah, man. So this one here is when you say that when you differentiate a constant, it is equals to 0. So the differential of a constant is always going to be equals to 0 because 0 times anything is 0. It no matter how much things come after it, it is 0. All right. So I'm going to go through some more questions, but just to review this one here, let me put on this thingy bob so you can see. All right. So at that point, I gave you the function where you see the spotlight, 4x squared plus 3x minus 5. You are required to find the differential. What is the differential, sir? The differential is a rate of change. It's a rate of change. How does differentiation help me, sir, in life? And I'm not going to start with the individual, but I know the person can ask me, sir, oh, why we have to do this? Oh, this is going to help me. It does, because a morning night this morning, trust me, I should be on my way going to the north south. I'm going to just drop off into a little hotel, even for a day pass, at a minimum, just a day pass.
Cool, sir.
No, man, no, man, me no man go, hey, Romain, I know, if Peter get talk about market, me not go to market today, man,
no, to Peter Gay, sir. Oh, relax, man.
Relax, man. Peter Gay, me say, matter of fact, he say, at a minimum day pass, but the real truth, me want to go down for a couple of days, me want to get lazy, me don't want to spread up on bed afterwards, more somebody come spread it up for me, me want when I wake up, me can go bathroom, go freshen up myself, and then me just walk straight to the dining room and yam some food, and then we can come sleep it off and then go eat food again. Me just want, me just tired. I mean, I'm not tired, don't get me wrong, I'm not being selfish. We know I'm tired, only tired too, but that's just where I'm at. But let us get back to real life. We have to be here in class, so snap out of it. But where I was going with that though is when I catch the boat, round about Monique, yeah, because when I catch it, Linstead is almost flattish. Yeah, when I catch that boat, come out of Euroton and going into Monique side there, just start to climb the hill. And trust me, you have some very brutal hill on that north-south. So sometimes when you're driving on the north-south, you see the car, and irrespective of how fast your car goes, none of them don't drive fast car like me because me just upgrade to an X7.
Lie. Same old vehicle in my drive. Same Mitsubishi Blue. Lie.
You can't just come on, crop rice doing it. So I just bought in my head a nice X7, BMW X7.
That
right?
sound right, and there's no such thing as an X7.
Be quiet, not sure. Me, I'm my head by. My head by. And the car that can move, But the truth is, irrespective of how fast a car can go, after a while on the highway, you are now going against friction because you're actually climbing. So especially if your AC is on, there's going to be a strain in the vehicle. So how does this relate to the math? You're actually finding the gradient, the slope, which is exactly what we're finding here. So when we're finding dy by dx, we're actually finding the slope. We're actually finding the gradient. So anytime you do a differentiation, you're finding the gradient. And another word for gradient is slope. What it is that you're doing, you're finding the rate of change of one variable to the next.
So dy by dx is equal to the gradient?
Absolutely. Absolutely. So what is happening now? Sometimes when you drive on a highway, you will see they say that slope is 6%. And sometimes when you're going on the other side, on the side of on the thing you see, and sometimes you go, it says slope 8%. Rockstone, it means that the slope is getting steeper. All right? 8% and then something there. So whenever you're finding the derivatives, you're actually finding the rate of change of one variable to the next. You said I'm moving to Newton-Raphson. It is going to come in even more beautiful if you for want of a better word, to see how this rate of change takes effect and how it comes into play. All right. So what I'll try to do is to bring some real life stuff into what it is that we're doing, so it is that you can appreciate the mathematics a little bit more. All right. So when you look at y equals 4x squared plus 3x minus 5, what it is saying to me is that I'm differentiating the variable y with respect to x. That's why we have dy by dx. I'm differentiating y with respect to x. All right. Now, you know what I want for you to understand, Everton. What is almost very difficult too is that last night I had a class from 5 o'clock to 9 o'clock, and
sir, I have a class every single day. I sit down in front of my computer from 8 o'clock, and class start at 5 o'clock and at 9 o'clock, and then I have to go into my group for all of the coursework them and capstone and presentation till after 1 in the morning, sir.
And I know
so you have
guys,
it better than me.
No, that's what you thought. And you guys, I know you guys in particular. As I heard, one of my good students, JP, spoke. Not JP, it was Namban who spoke about why capstone has to be at this particular time. And the response that the VP gave is that normally when you do it's true. Normally when you do a course, the capstone comes at the end because it now brings everything that you would have studied into play in order to do that capstone project. But guess what? I know and this is why I avail myself for this group in particular, because I know you guys have some heavy stuff doing, right? On a bright, because on studying computing. I am just trying. That's why I studied math. Let's go. What I want to say to you, so last night I was having a class with the students and I was saying something to them, and while I was there talking, I went and looked in the chat and somebody put an acronym in the chat. And I stopped and asked the student what does the acronym mean. And the student told me. And I said, oh, I say, you know about it? Or you just Google it. And, he thought I was being cheeky. And I said, no, I'm just asking a simple question. Just respond to me. And he says, his father does that type of work. I said, so what I'm talking about is true? He said, yes, sir. I said, okay. So often like speaking about things in class, where even one student can relate to it and can say to the classmate, no man, what sir talk about is true. Hold on. Sorry. What sir talking about is true. Sorry. So this is what I'm going to say to you. You see, when we're climbing those hills, going on the North-South Highway, Coast Highway, I want you to believe that there is an equation. There is an equation that can be calculated. So the people that at MSWMA, not MSWMA, sorry, at Works Agency knows what equation is given by the slope at different points on the highway.
Sir.
Yes, sir.
I have a question. You said when you started with this example, you said something in the line along the lines of the gradient, right? And a specific point of going to Mobi, there's a degree of 15% slope in the road, right? Cool. So when you look at it from that aspect, when you're saying you're finding the derivative,
yeah.
Saying?
Yes, sir.
So say the gradient is 15, right? So you're saying that the first derivative of that is when the gradient would have changed by a certain amount, and then that would be the derivative of the 15?
Yes, sir.
All right, cool. Thanks. Sorry, continue what you're saying.
Watch this now. So, so I'm giving you this line, Everton, and this is my X7 that I just bought. All right.
You get robbed.
So what I'm saying to you is, I'm climbing a slope, and it looks steep. But because I'm in an X7, it really don't mean anything, because it kind of feel nice. Huh? So all right. So this is my y2, that's my y1. This is my rise, that's my run. All right? So this is a distance that I'm covering along my x-axis. And of course, you can see the distance that I'm covering along my y-axis. So I have two axes and I'm trying to cover a distance, right? Now, when I use y2 minus y1 over x2 minus x1, and it's equals to m, and m the gradient. And I remember, and I know you guys would know this from even discrete mathematics, when you're doing, them little something there. It's a play math course. This is actually a differentiation that you're doing, but we never tell them the time that says differentiation, y2 minus y1 over x2 minus x1. It's really differentiation. But guess what? I'm going to reintroduce this to you sometime today, because my aim is to go through unit 1 today. I want to go through and present the stuff, and then we can do a review on it, because I'm finishing off the syllabus. I have all intentions to. So look at what is happening here. So this is a straight line. This is a straight line. And for this straight line here, a straight line is a function, for argument's sake, that is linear. So I can say to you that that would have been, say, call it 5x minus 3. Sir, how do you mean 5x minus 3? I'm just giving you an example. 5x minus 3 is a line that is linear. Once a coefficient of, not a coefficient, once this here is 1, it means that you have a linear graph. And linear graphs are straight line. All linear graphs are straight line graphs. So any equation of the form, or any function of the form ax plus b, is a linear equation. It means that the variable is raised to 1. If I give you ax squared plus that, is a different function and it don't look like a straight line, right? So all straight line graphs are graphs that have a power of 1. So I'm giving an example of this one. So it means now that dy by dx is going to be equals to
all what?
All straight line graphs are linear graphs, or all linear graphs are straight line graphs.
No, you said something about a power.
Right. So the power is raised to 1. Linear graphs, the highest power is raised to 1.
All linear graphs have a power raised to 1.
Power, yeah, man. And if it is greater than 1, it is called a quadratic. If it is greater than...
Hold on, sir. We can't answer that. Hold on.
So I'm saying to you, if the power is 1, if the power is 1, graph, you're going to have linear. If the power is 2, you're going to have quadratic. If it is 3, you're going to have cubic. So forth and so on, right? So the highest power in the graph, you're going to have a linear graph, which is a straight line graph. A quadratic, it can slope up so, down so, or it can slope up so. And again, I am going to come back to this, because this would have been calculus 1 when you talk about stationary points. But in calculus 1, you are required to do stationary points for single variable functions. So I'm only going to refresh your memory on the single variable functions for calculus 1. But for calculus 2, we are going to be finding stationary points for multivariable functions. All right? So for quadratic graphs, it either shaped down like an N or up like a U. And for the cubic graphs, it's shaped very sexy, curvaceous, right? And it can go that way, or it can go that way, depending on it being negative or positive. All right. So you notice. Let's go back to this one here. You notice what I would do. What I would have right here for my answer is 5, because remember, look at the function y equals 5x to the first. I'm using that 1 to multiply 5 to give me 5. But remember, now I have to subtract 1 from the power. 1 minus 1 is 0. And x to the 0. Oh, but sir, you did say that anything raised to the power 0 is 1. Very good. So my answer is only going to be 5. Then sir, 1 to the minus 3. Remember always, the differentiation of a constant is equal to 0. The differentiation of a constant every single time. And I just proved it to you, right? Because that constant, that -3, beside of it, you have -3x to the 0. And when you use the 0 to multiply by the 3, you get 0. All right?
So when you raise to the power 3 is what again? What we are scribble down this?
Cubic.
Cubic.
Yeah.
Okay.
Right? So so what is happening now is, so this is exactly what is happening. So when you so the point is, Everton, so when you go into Mobi, there is a steep slope somewhere. So that's the point I'm making. So the point the point is that at different points along the journey, you can have and will have different equations. At different points of the journey, you can, and this is how the man them said, here the plan, no, this part is too steep, so we need to advise the motoring public that, you are going to be approaching a steep section. And sometimes they will say to you, open your window, turn off your air conditioning unit so at least you can get more power. And then what they advise the heavy duty vehicles to do is keep to the left. Keep to the left. And I think that lane, the soft shoulder is even wider. Keep to the left, because chances are, especially if you're carrying merchandise, chances are you can, the vehicle can become disabled, and you don't want the vehicle to be disabled in the middle of the road. So you advise your motoring public to, you're driving a car or a vehicle that is, going to go slow. Keep to the left. Should in case you break down, at least you can go on, whatever to do is whatever, right? So this is also a practical aspect of the differentiation. Remember, when I'm finding dy by dx, I'm finding the slope. And another name for slope is gradient. When I also find y2 minus y1 over x2 minus x1, I'm finding the gradient, which is the same thing as the slope. All right? So when I do all of that, that's exactly what it is that I'm calculating. All right. Let us go with a few more of these examples. Let us go with a few more of these examples. Let me give you about 5 of them to do. No, let me give about 3 of them to do. Do now. I want to find dy by dx of the following here for me. 4x to the 4th minus 8x cubed plus 2x to the, call it second, plus 1. And then in this case, I'm going to give you p is equals to r to the 7th plus 2r to the 5th minus r. And then the other one, I'm going to give you s. The reason I'm mixing it up, I don't want anybody to think that we only work in x and y, because there are times I will give you a question that contain different variables. All right, so don't worry about it. So a to the 5th plus 7a to the, call it second, minus 2. All right, so in this case, let me just help you out right here. In this case, it's going to be dy by dx. In this case, it's going to be dy by dx. In this
Don't
case,
skip no step.
I'm not skipping a step. No, it's okay, but I'm just showing you something. In this case, it's going to be dp by dr. And in this case, it's going to be ds by dA. So what the point I'm making here, because I want you to do this exercise, so the point I'm making here is sometimes we only give examples in x and y, and students only believe that we can find the derivative in x and y. No. So dy by dx is just finding the rate of change of y with respect to x. In this case, the function is given as p. P is equal to r to the 7th plus 2r to the 5th minus r. So when I'm differentiating the function with respect to p, I'm going to get p of r. Similar to this, the function is given in s. So s is equal to a to the 5th plus 7a squared minus 2. So when I'm differentiating the function with respect to s, I'm going to get sa ds by dA, the differential of s with respect to a. I'm going to give you 5 minutes. You don't really need as many as those 5, but I'm going to give you 5 minutes to individually work on these, and then I'll come and do them. Start, please. 1 minute.
Okay, what wanna do? Jesus Christ, man.
Who agrees with the first one?
Yes, sir.
What was that, sir?
Who agrees with the first one? I did the first one. Who agrees with it? Agree with it, Ramin?
Yeah, man, sir. Good to go, man.
I agree.
Anybody disagree?
No.
No, sir.
Nice.
Correct.
Very good start. Very nice. This is what I get for this one.
Oh, sir.
Mm-hmm.
Sir, I thought you had two y squared.
No, but oh, this parchment?
Yes, sir.
Me can't give you in the something parchment, man.
Sir, that's why. Yeah, funny
Parchment,
that.
you know my drawing already, man, parchment. Sure, you're going to kill it.
Cause
See
sir,
the
I'm
man.
doing it, sir, but it look like
Sir,
a
you
Y.
didn't fix up your writing, man.
Anthony, it look like a Y, so me now keep.
Listen to me. A Saturday morning and you never wash your face and the matter still in your eyes, so you not to properly. I want you and Candice and Shanice to leave me alone. All right, it's an X.
All right, sir.
All right, cool. What about the second one? 7r to the 6th plus 10r to the 4th minus 1?
Yes, sir.
Yes, sir.
All right, sir. Well, I never get the 7r to the 6. What I did put, sir, was r to the 6. So I see where you're basically times it. Nothing is in front of the r, so
no, say
1.
so. No, say so.
What you do?
Dress up the talk again and say, what is in front of the one, Romain?
1.
A 1.
Yeah, that's what I said. There's nothing in front of the r, so a 1.
No. Well, don't say nothing in front because.
Oh, all right. I'm not gonna say that. 1. The value would be 1. Yeah. So times by 7. Just to get the 7r60.
Romain, you know, you saw that Mr. Russell when he talk. Anybody ever tell that before? 2, 3. Now you saw that Mr. Russell.
That is not a good thing.
Okay.
Just saying.
Change topic. Lord, why did I say that? Change topic. So, Romain, what you need to recognize is that there is indeed a 1 in front of it. So it's not nothing. There's a 1 in front of it, right? So it's going to be 7 times 1. Very good. And then the last one now. What's the answer for the last one? Somebody tell me.
Would that be?
I think it's 5a raised to the power of 4 plus 14a.
Yeah.
That done this.
All right. Cool.
Yeah, man, that's it.
Why the minus 2 come back?
Okay. No, because
the minus 2 come from, sir.
And that's why I'm silent, because I'm hoping that somebody says, sir, why you put the minus 2?
Come here, see where that comes
from.
Okay, good. Very nice. I'm happy. You guys learned it. Okay, very good. I just put it here because I wanted to see if anybody would recognize what I did. Excellent.
Sir, that DS thing you kind of...
It's not there's nothing different with the DS and the DY. I'm just putting that here to show you that the function don't always have to be in X and Y.
Or DA. Sorry, now do that again, sir. You stress me out.
No, man. The function don't have to always be in X and Y. It can be in anything else. All right. Very good. Excellent.
That's why I have to do over Eddie Koval 4 times, 5 times.
Bless the Lord. All right, let's go. I'm going to give you. All right, so what it is that we just did a while ago was a chain rule, right?
Oh,
so
hold on. Don't wait. That's the chain rule. Okay.
Right, that down.
Because it's like you talk like you don't realize. So when the semester done, all of the thing them take time trickle out the first 2 weeks. And
Talk truth, man. Talk truth.
No, man, it will stay. It will linger.
Yeah, it's a linger, like programming. It linger, but you don't remember nothing. Remember, maths are the most ungrateful course you can ever do, sir.
Oh boy, I keep saying to you guys that you're the bright ones. You're studying computing. The bright ones studies computing, and the not so bright ones do math, which includes me. Now let's go. So that is the let's call it now. That is the.
So going on to a different topic now, sir.
No, man, same topic, same review on differentiation, but a different method now.
All right. So what the name of that method there, sir? I'm right at the top of the book.
It's
sir.
the top of the book. I want to write this: PRODUCT.
Product rule.
Yeah. Okay, watch me now. Let's see now. 1, 2, 3, 4, 5.
All right, so sir, first thing is first. Give me the rule.
That's exactly
apply here. So now
that's exactly where I'm going. So what I was counting just now are the students that I would have taught calculus 1 to. And I'm seeing all my calculus 1 students here, so most of you should know the method that I use. It is the first times the differentiation of the second.
Sir, you know the name? Familiar with the name, sir?
Yeah, man. Hello. Peter gave what words? Me know you did the calculus 1 with me. I mean, no, so you know this already because you didn't do it.
Yeah, I don't remember it. Like literally, I remember. Just know the name.
yeah, man. It have something to do with this.
Yeah, man. So it is the first times the differentiation of the
second
plus the second
times the
differentiation of the first. Right, and that's it.
All right, so write it on the board now. Stop. Right. Write it, man. In words.
This thing needs to change. So it's the first times the differentiation of the second plus the second times the differentiation of the first. Something that is very useful that I think you should all write, that you should try and remember, because this course is a course on differentiation and integration, and you don't know what integration they will give, what differentiation they will give you. So it's always very useful for you to be very sharp with your differentiation. As a matter of fact, if you don't know how to differentiate, which is why I'm going through the review of differentiation before I even get into Newton-Raphson or approximation or whatever else, the differentiation must be up there. So the first times the differentiation of the second plus the second times the differentiation of the first.
So the question now, sir. Okay.
So I'm calling one of them the first and the other one the second. All right, watch me. Don't talk. Don't move. Just watch what I'm doing right here. So dy by dx. Listen to me. Is equals the first times the differentiation of the second. When I differentiate the second, I'm going to get just 1. Because when I differentiate x minus 1, the differential of x is going to be 1. The differential of minus 1 is 0.
No shortcuts.
I'm not shortcutting.
Yes, you are.
Nope.
Yes, you are. That's a shortcut in mind.
No.
Yes.
You know a while ago. When I gave you, what did I give you a while ago? 5x minus 3. And I showed that the differential of 5x minus 3 was just 5.
Yeah.
So I'm saying to you now, what is the differential of x minus 1? Remember, the minus 1 is a 0 when you differentiate it. And the differentiation of the x is just going to be 1. So that's why I have times 1. So it says the first, I'm writing it back the function. The first, I'm writing back the 2x squared. Times the differentiation of the second. When I differentiate the second, I'm going to get 1. Plus the second, I'm writing back the second. Or incidentally, those are not full stops here. In big school, write this as a multiplication sign. Plus the second times the differentiation of the first. Now I'm differentiating 2x squared. When I differentiate 2x squared, what do I get?
4x.
Very good. Question done. Let me go again. It says the rule says the first times the differentiation of the second plus the second times the differentiation of the first. The first times the differentiation of the second plus the second times the differentiation of the first. Hear me out. Get a flashcard, get a cue card, or send yourself a voice note of it and keep playing the voice note until you remember it. When you remember it, Every time I do a question on differentiation, just say the first times the differentiation of the second plus the second times the differentiation of the first. I guarantee you, you will get it. But you have to practice it. So my first is my 2x squares. So I said the first, anytime I call the first, I'm write it back. See here, first, that and the first are exactly the same terms. The first, write it back, times the differentiation of the second. So now I need to differentiate all of that. X minus 1. Now the differential of x minus 1, it's going to be 1 because the differential of x is 1. That's a chain rule. Think of a chain. You have different links. The link between the x and the 1 right there is a minus sign. So when I differentiate x minus 1, I'm going to get 1. And when I differentiate negative 1, I'm going to get 0. So the answer there is just 1. All right? Plus the second. Now, I call the second, so I'm going to write back the second, x minus 1. See there? X minus 1. Times the differentiation of the first. Now I need to differentiate the first. The differential of the first now is going to be the differential of 2x squared, which is the first term, is going to be 4x. Remember, you take the power and you multiply it, as Romain said, you multiply it by what in front of the variable. So it's 2 times 2 is 4, and you reduce the power by 1. So it's going to be 4x to the first. Sorry, 4x. Done. So the differentiation ends right there. What is left now is just me doing some algebra. So I'm going to have dy by dx is equal to 2x times 2x squared times 1 is simply 2x squared. And then now I'm distributing the 4x over the x minus 1. So 4x times x is 4x squared. Let me just show you something. I'm saying 4x times 1, and then I'm saying 4x times that. Give me half a second, please. Half a second, 1 second, 1 second. Yeah, man, sorry about that. So I am using the 4x to distribute over every single thing inside the parentheses. So I'm going to say 4x times x is 4x squared, and then 4x times negative 1 is going to be negative 4x. It's going to be negative 4x. And then I'm just going to group my terms together. Grouping my terms together, you recognize that these two belong to the same family. Oh, you know that, sir? It's x squared and x squared, right? So I'm going to say, okay, dy by dx. Right, I must change this tip today. Must change this tip today. Dy by dx for 2x squared plus 4x squared is going to be 6x squared minus 4x. And that's my answer. If you want to show off and say, boy, you know what you can do, you know, if the question says to you, put it in its simplest form, you can factor out and say, boy, this is going to be 2x into 3x minus 2.
Sir, don't
Yes.
put that on the fine. No put no factorization on it.
Yeah, and I don't have to, but I mean, it's I don't have to because I mean, you remember, your differentiation would have really come in calculus 1. So when they're really testing you up, no, I shouldn't say that because in the calculus 2, they ask you to do the differential of exponential functions. Yeah,
Jesus.
yeah, man. You have to do the differential of exponential functions. Yeah, but you'll be fine. So that's what the product rule looks like. That's what the product rule looks like. What is important is the first times the differentiation of the second plus the second times the differentiation of the first. First times the differentiation of the second plus the second times the differentiation of the first. All right. Start for me, please. Look at what I have and try doing that on your own. All right, anybody finish it?
Yes, sir.
No, okay. I stepped away because I don't like my, very nice for me. I don't like my other thing writing and Shanice a text step with me. So I'm trying in the process of changing the tip. And let's hope it's a tip in please. But Shanice is a lot of me. I said, sir, you thought about the pen not writing properly. Are you clever? I guess. Already. Let us see. Keep fingers crossed that this new tip will make a difference. All right, am I allowed to switch my screen? 6x cubed plus 4x. All right, thanks for answering. 6x cubed plus 4 plus 6x cubed x plus 4. 6x cubed x plus 4. No, it wasn't a tip at all because the 3 not forming properly. 6x cubed times x plus 4. All right. Now, the first times the differentiation of the second plus the second times the differentiation of the first. The first times the differentiation of the second plus the second times the differentiation of the first. The first times the differentiation of the second plus the second times the differentiation of the first. Particles on it. All right, let's go. So dy by dx, oopsie daisy, dy by dx is going to be equal to the first times the differentiation of the second, which is 1, plus the second times the differentiation of the first. Oh Lord, the differentiation of the first is 6 times 3 is 18. So that's at 18, and then sir says to subtract 1 from the power, so it will be 18x squared. Everybody got that?
Sir, it was
Yes, sir.
Yes, sir.
Sir, me fight and cuss, sir, but that me get.
Okay, very nice.
Me get that part.
Very nice. Shans, let me hear what you say, Shans. So you saw something different, Shans?
no, sir. I thought it was 6 x raised to the power of
2?
2. Yes, sir.
No, it's cube. You have to look at it, man. It's cube.
I don't know why. All right, 2. All right, sir.
Good. So it's going to be dy by dx is going to be equal to 6x cubed times 1 is 6x cubed plus 18x squared times x plus 4. But watch me now.
Hold on.
Yeah,
why you rearrange it? Oh, you're
because,
grouping. Oh, you're grouping.
Yeah, I just put it. Yeah, it's just presentation. You know, just presentation. Right? I put the single term in front of the double one.
All right, cool.
All right, watch me now. So Everton said, I could just leave it like that, no? But I want to show you something, and I want to break it into the correct habit from now that we're doing a revision. The correct habit is whenever you see, and I'm going to put that in green, whenever you see something like that, this could also be written as dy by dx is going to be equals to, I'm factoring out, and I can get out a 6x squared, and what I'm going to be left with is going to be x. 6 times 3 is 18, so it's going to be plus 3 times x plus 4. So why you have to do that? Because there are times when you are supposed to be doing the differential of the exponential function, you have to use the differential of the exponential function because you know them love figure that in a Newton-Raphson, them love figure that in a what do you call it now, in a Maclaurin series, and them love to push up the exponential function in a different something. And when they put it like that, the truth of the matter is you have to simplify. Because especially when you're doing Maclaurin, remember when you do the Maclaurin's expansion, if they say up to and including the term x to the fifth, it means you have to differentiate 5 times. Because the mere fact that them say x to the fifth, it means it's 5 times. And after differentiating, remember, you're checking at the point where x equals 0. So you have to go put x equals 0 in all of something. So you have to go fix up at some point. So let us get in the habit from now. So let us just double check to see if this is correct. 6x squared times x is 6x cubed. 6, okay, and let me do this one. And 6x squared times 3 is 18x squared. So that is correct so far. So the final thing.
Hold on there.
Mm-hmm.
Go on again. Or factorize that.
I'm factorizing, very good.
Oh, okay.
I'm factorizing. So the next step is to say dy by dx is going to be equal to the 6x squared, and then I'm going to just work what is on the inside. That is going to be, let me work on the inside up here. So Mr. Everton, don't attack me. Plus 3 times x is 3x, and 3 times 4 is 12. So that comes out to be something nice now. 1x plus 3x is going to be 4x plus 12. Answer.
So when I start, we use the green.
You get lost. All right, no problem. No problem.
Recall.
All right.
I use the magic.
All right. Let me tell you what it is. And I kind of suspected it. Because the truth of the matter is the differentiation ended right there. Right? But as I said before, you are going to be required at times many times to
all right, sir. Hold on. So you have okay, in the second line here, you have 6x cubed, right?
Mm-hmm.
So why do we have 6x squared in the
because I'm factoring out. I'm looking to see what is common here in that term. So in the first term in that line where you see the stuff,
so you remove one from that and then one from that. Okay.
But look here, there's an 18x squared right there, so I'm looking to see what is common between this 6x cubed and the 18x squared.
And then what is common?
Very good. What is common is going to be 6x squared. Sir, how you know? Because 6 is a factor of itself, and 6 is a factor of 3. Of 18.
18.
To give me 3.
3 times 3, 3, 6 is 18. So you put the 6 there. So
I put the 6 there. So right. And look at this one now. This is x cubed. You can see that?
Yeah.
And this is x squared.
So you're going to remove the x squared
from that. Take out the lower of it, right?
Yeah, take out the x squared, and then that's going to leave just the 6x there.
6x. Right, but no, just really 6x squared. But what is going to happen here is when I multiply this 6x squared by this x now, I get back what it is that I start off with.
Yeah.
And when I multiply this 6x squared by this 3 right here, so Peter again, 6 times 3 is 18, 18x squared. So I've gotten back my stuff.
Oh, 3.
Oh, yes, sir.
But sir, where got the bracket x plus 4 right here?
Because remember, in this term, that term is not just 18x squared, it is 18x squared times x plus 4. So that term is long.
Oh.
That term is Williams Campbell, the double barrel name business. Yeah. Yeah. So when somebody named Williams Campbell I got signed for one form, he got always run out of form, run out of space, because spare last name too long. Right? So this is what is happening now. So look here. So look at what is happening now. So when I multiply this 6x squared by all of this right over here, so I'm going to get my 18, 6 times 3 is 18x squared times the x plus 4 times the x plus 4. And that's what we get as our answer. Yes, sir.
Sir, yeah, make some sense to say. Look like we're going to need for this one.
Just get it.
Yeah, just no get problem. Where you say, sir, but
no
you have to be too kneeling at the coffin, sir.
No problem. All right, and let us look at the last line. The last line now says, it's just for me to fix up. You know, the food cooker, me I share it properly now. I'm put the vegetable one side and the rice one side and the little oxtail and the beans over the next side. Watch this. I'm saying, I'm fixing up this term, so the x stands alone.
Yeah.
So I write it back. This 3 times this x gives me 3x.
3x. Yeah.
That 3
times 4 give you 12.
Very good.
Nice.
Romain, unmute for me, please, Papa. All right.
Yes, sir.
This is you now. What is this plus this?
4x.
How you know that?
Because you have 3x already, so you just add 1 to it.
X is equal to 1.
No, stop it. Rubbish this. X is not equal to 1. X is not equal to 1. So, you know why I answered the question, Romain? Because remember now, guys, x is not equal to 1. Please, x is not equal to 1. The reason I asked Romain to unmute is because when I was doing the differentiation with the x r to the 7,
the x would basically be 1.
No, x is not 1. Don't say that. X is not 1.
I saw it a jam in our heads there.
So what I'm trying to get at you is that there is, let me put it in a different color so you can see it.
So the coefficient,
there is a
there is a 1 there.
There is a coefficient in front of the x that is a 1. Yeah. Now, let me stop and just address that issue because it is very important. I asked you to unmute, Romain, because of what it is that you said to me. And you know, this is the importance of students speaking to me. I mean, it's like I'm repeating myself. It's like deja vu. I'm in this morning's class is a class I had last night. And it's the same thing I said to them last night, I'm going to be saying to you now. What is important is when you speak to me, and I say unmute and talk to me here, so you just allowed me, Romain, to get into your headspace. And get into your headspace, I was able to also get into Everton's headspace because Everton says to me, but x is basically equals to 1. No. And then you came up with something to say, but yeah, man, because of basically 1. I said, no, that's not true. And then Everton went into his repository to say, but sir, the teacher something before and talk about coefficient. Sir, it is basically the coefficient is 1 then, right? Yes. So the point I'm making is you have the information. It's for me now to allow you to correctly use the information. So I'm going to say it again. There are some of you who are in here and who decides to not talk. It is important that you speak so that I can hear the misconceptions that you possibly have. Tevon Davis, that goes for you. O'Shane Johnson, that goes for you. Sir Palmer, that goes for you. Well, Kimani, they kind of open it mouth one time. Miss Nicholas, that's you. Dawson, you did open your mouth one little piece of time, but I need to hear from you. Kamar, you open your mouth one little piece of time and say, sir, that look like one why? But I need to hear from you. Alton Brooks, you are not here. You are not here. So I want you to speak. It's a class. It's an interactive class. If you come to my class and you know how I stay, you know how I stay. And guess what? A long time I do this, I mean, I think we can change. I need to hear from you. I need to rent a space into your head so that I can dust off the information and put where you want to use at the front. Please speak so that I can know. Don't tell me, say, sir, I'm understanding. And even if you understand, tell me, say, I understand, so me can know. But importantly, be true to yourself. So if you don't understand, trust me, you're not going to impress me. If you say, oh, sir, I'm understanding, I will know. And I don't want to know when it's too late when I'm marking the exam paper. All right.
Sir, so could I leave it to where it is up by the second line here?
The second black line?
Yes, sir.
If you are doing, all right, this way. This is when you at home cooking rice and peas, Shan. So I know you can cook. You cook rice and peas. I'm Chinese, don't pay no mind here. You cooking rice and peas, Shans, but you don't use one of those sieves at home where you can capture your pimento. So when you share the rice and peas and the oxtail and bean and give me to eat, one or two pimento grains will come out in there. You know what I talk about? No, when you cook a soup, you have a little pimento inside that time.
Yes,
it's a pot, right. But this piece when you cook and you have a pimento grain in there. The one you don't hear so now, I remember go to a hotel, like right about now, me in a Montego Bay, I don't know where you guys are, because me start my journey a long time. So me in a Montego Bay, my X7. And when we go eat them food later, because it's big 5-star hotel, them now gonna have no seasoning, no pimento, no garlic, no scallion in the plate to them serve. Because what they do, they use a sieve, a strainer, that they put all the seasoning into like a little clip balloon something, and drop it in the pot. And when them finish cook, them take it out. So every bit of the seasoning come out because they know that. Me nothing said when me cook in my yard, me not get pimento in my plate. Me get pimento in my plate. I mean I have none of the fancy something them with them use in the hotel. Me only see that when me I go teach down at tourism and them show me the something, eh? So the point I'm making, Chance, is you cook your rice and peas or your soup or your yard, it tastes nice. Even nicer than the one at the hotel too. Right? So both of these answers, the point I'm making, are correct. But it just depends now on the presentation. So the presentation for this one is fine. But you can go and present it even a little bit better down here. So
Sir, all right.
So one quick question. So let's say the last one, like where I would agree with the dy dx 6x whatever. You say name some expand something like name.
Factorization. So I'm actually right. So when I'm multiplying all the stuff now, I'll be expanding it again. So if I say 6x squared times 4x and then 6x squared times 12, I'll be expanding.
All right, watch me now, sir.
Yes, sir. I get what you're saying, sir. But like you know, say, like when I ask, say, okay,
like this one piece again.
Do dy dx. So I get it in, sir. But you say like it might ask you to do something else.
That one. Oh, it is not expansion then. Yeah, man. Okay, yeah. Yeah, it's not expansion because that's why I brought up this screen here to show you. So it's not expansion then. What they will ask you to do is sometimes they will give you some information. So they will say to you, calculate that will be more calculus one, when you need like parametric equations, and they will say to you, something is equal to something else, something else equals to something else, and then they say, calculate the gradient at this particular point. Right? So it means that when you calculate dy by dx, you can substitute a value in there. In that case, Peter, I hope I don't lose where it is. I hope so. Yeah, right here. So in this case, Peter, if I ask you to calculate the gradient at a particular point, you could have do something from up here. So you could have do from if I said to you, calculate the gradient at the point x equals 1. There is no need for you to do this and no need for you to do that. You can stop it right there, so, and just put in 1 into the function, and it's good to go. Real talk, good to go. All right? But yes, Peter, you're correct. It depends on what it is that they're asking. It tells you how far to go. It depends on what it is that they're asking. It tells you how far to go. All right? Okay, let's go. So I would have given you. Okay, so I have one other thing to look at with you, and then we'll move into the. Remember, still recall that we're doing here now. We don't start with calculus too. Recall. All right, let's go. Quotient rule. It's actually writing better. Quotient rule.
Sir, what is that? The determining times times that?
No, man, the denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator squared. So it's the denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator squared. Let's go again. The denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator squared. So it's the denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator squared. All right, I need to undivided for about a minute. So you're given y to be equal to 2x over x plus 1. Y is equal to 2x divided by x plus 1. And they ask you to find the derivative of this function. What do you mean by derivative, sir? To find the differentiation. All right? So you're going to be saying dy by dx is going to be equal to the denominator. The denominator. So you write it back. Times the differentiation of the numerator. Differentiation of the numerator is going to be 2 minus the numerator. Minus the numerator is 2x. Times the differentiation of the denominator. Differential of the denominator is going to be 1. All over the denominator squares. All over x plus 1 all squares. So it's the denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator squares. So look at what will happen. I don't want to switch my screen. All right, you know what I'm going to do? I want you to see everything in one shot. So let me just write this one up top here so that I don't have to use another thing. So let's go again. Dy by dx is going to be equal to the denominator, x plus 1, times the differentiation of the numerator, 2, minus the numerator, 2x, times the differentiation of the denominator, which is 1, all over the denominator squares, which is x plus 1 all squares. All right? Now, my final thing now is to do dy by dx, 2, watch me, 2 times x is going to give me 2x. Watch me. 2 times 1 is 2. And 2x times 1 is 2x, so you get minus 2x all over x plus 1 all squares. Watch me. Positive 2x cancels with negative 2x. Watch me. Dy by dx then is going to be equal to 2 all over x plus 1 all squares. And that there is my answer. Ask me your questions now.
Do it again, sir.
All right. Thanks for asking. Let me just give a caution of these guys. It is one thing to sit in my class and to understand what it is that I'm saying. It's another thing for you now to go through. Yes, please. Hello?
Sir?
Go ahead.
Come back to me, sir. Everything still come back to me.
I don't hear what you're saying. So, Lando, you said something a while ago? I went out a while ago?
Everything is slowly coming back to me, sir.
Oh, yeah, man. Absolutely. Romain, you were saying something, or Kemar? Which one of you were saying something else?
Me, sir.
Sir,
then say leave the denominator as is. The denominator as it.
Yes, sir. You never expand the denominator. Okay. Very good question. Never expand it. Make it stay with it. Never expand it. Very good question. All right. So it's one thing for you to understand, and I'm happy that it's coming back to people. It's one thing for you to understand what I'm doing. It's another thing for you to go home now. Well, you're at home. For you to reinforce what it is that you are doing. You have to reinforce it. Guys, don't wait until next week, Saturday, before you open the book again. Take up the something, man. Write it down and start practice, and more practice. And guess what?
As soon as we're done the presentation, I'm sure we'll have.
No, Romy, I'm going to take Nixon and lick it down, you know what I mean? No. Roman, let me tell you why I said no, Romy. Because full presentation's never done. Remember, you know,
remember this meeting is recorded. Threats of bodily harm
it's true.
can be
Romain, I'm gonna
understand the banter. Sorry,
Romain, I'll pray for you, Romain. No, don't say that, Romain. I'll pray for you. No, but on the truth, the truth is, work not done, it not go done, and we don't ever can have a serious task at work. I mean, no, and because I know where he works, I mean, him talk, and I know you have willing for something to do to me. No, me not even ask you. Me no. But you know what is important? Before I go through this thing, just listen to me 1 minute, guys. And I want to try it. You see, when you try it and it don't work, come back to me and say, sir, me try it and it don't work. But I'm going to give you one of the secrets that I use. I did some very difficult courses in my areas of study. And courses that make me...
But sir, sorry to interrupt, but what you can do is like, see, now we only have class once per week, right? You can just give us a good amount of questions for us to do.
Absolutely.
So we can practice.
Absolutely.
So we can call you and bother you.
Well, we're both here. You know, the question
in block your number and answer you 2 months later.
Whatever. Peter, you don't you call me, you get through to me, Peter, I don't know what is wrong with Everton.
Why is it Everton that when Everton call you don't answer? Even when you're online at 3 o'clock in the morning, you will not answer. But now so nothing still.
You know, I need to go incognito. But anyhow, the point is, work now got done. And I'm going to tell you one of the secrets that I used. I did some very difficult courses that caused me to shed eye water. I mean, not like you. If me tell you something about ball when I go to school, serious eye water, and especially when I was in my bachelor's. When I was in the other courses, no lie. When I was in another degree, one teacher one lecturer give me something to do. After me think I've done the course, you know, call us back, and maybe quite a number of us got A's, and she decided she can't carry A's and give us something for God to do. And me put it down until the day of the day before the submission. I recognized I couldn't finish the stuff. Remember, out of yard, I do something, and the yard I just come and just kiss the teeth and say, whatever. And it prevented me from getting my A at a B+ for the course. I shed eye water. But I'm going to tell you the truth is, I had to create a timetable, and that's what I told the students last night, and I want to try it. I don't know how many courses all of you are doing the same number of courses. I doubt it, because I know I may have 1 or 2 day students here. But here what I'm going to ask you to do. Even if you're doing one course over this summer, and this is the course that you're doing, I'm going to ask you to do me a favor. That you're going to sit and create a study timetable for all the courses you're doing. And even if it's one course you're doing, I want you to still create a study timetable. And I want you to be very deliberate in, if you say at 12 to 1, I am going to do some work. I can do some work. It's my lunchtime and I can do some work. Be very purposeful in sticking to that hour or 2 hours. So I want you to do it. And for those of you who work and can hardly take lunchtime, I want you to say, boy, you the plan. I'm going to go home 9 o'clock, 10 o'clock, and I'm going to get 4 hours sleep, 3 hours sleep, and I'm going to get up at 2 o'clock, or I'm going to get up at 3 o'clock and use 3 o'clock to 5 o'clock and do some work. You don't have to put the 2 hours to the maximum, but do some work. Spend at least an hour. And then if you develop that rhythm from now, I promise you, you cannot fail the course. Now, hear me out. Hear me out. I am not one who teach a course and my grade sheet don't look good with students. And I don't pad my grade sheet, but I want, when I finish teaching, students are supposed to pass my course. So I'm seeing a number of you in the class here. I'm seeing 13 of you in the class now, 12 of you in the class here. There's somebody who was here before and disappeared on me, but I'll find out. I want at the end of this summer, every Jackman in this class pass the course, and it is possible. Just be honest with your doings, do your own work, let me see where you are so that I can help you. So when I go on Edicasa and I see everybody getting their 100%, I am saying to myself, oh, they're understanding. So it's not giving me an opportunity and for the system to diagnose it, because the system can diagnose. I mean, I look at it, the system will say to me that Romain has a difficulty with quotient rule differentiation. You know what we can do? You can say, Romain, what is a good time for me to link you? I say, sir, we can talk now, you know. I say, all right. The denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator squares. So, you know, say, you just get the understanding. I said, go and do over the assessment. Right? That's how learning takes place. You can't put it down to the one once a week. It's not going to happen. So if you try it for me and it don't work, next week all being well, come and tell me, sir, I try it and it never work. All right, but please. All right, so let's go again. So you're given y equals 2x over x plus 1. That's the question. Where you see my spotlight is where it is that I have the question. The quotient rule says, and I'll pick up what it is that I mean by now. I've been purposeful to go through the rules several times.
Hey, sir.
Yes,
sir, yeah, share your screen, sir, but I can't see. How you get out of that something? I say I can't see back the screen. Oh, right, got it.
Okay, cool. So it's the denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator squares. The denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator squares. So, I know what the numerator is, the one on top. I know what the denominator is, the one at the bottom. D for down, D for denominator. All right? So, it's a denominator. So, I'm going to have this. When I call the denominator, I write it back. So, it's a denominator times the differentiation of the numerator. So, I'm looking at my numerator, and I'm going to differentiate the numerator. Now, the differentiation of 2x is going to be 2. So that's why I get times 2. So it's the denominator times the differentiation of the numerator. Then I'm going to minus now the numerator and minus the numerator. So see here, so the minus sign here, minus the numerator. So the numerator here, 2x, and minus in the numerator, 2x. Then I'm going to now differentiate the denominator. Differentiating the denominator is going to be 1. Because the differentiation of x is 1, and the differentiation of minus 1 is plus 1 is 0. So if the denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator, I don't finish yet, all over the denominator squares. So it's all over the denominator squares. So I'm going to put it all over x plus 1 squares. Here what Kemar asked earlier, sir, if we expand x plus 1, nope. Never. Please don't. Tantody. Now, again, my differentiation ends right there. But I have to be purposeful now in kind of fixing it up. So I am multiplying this 2, I'm multiplying that 2 into this bracket. So 2 times x is 2x. And 2 times 1 is 2. Minus 1 times 2x will give you that minus 2x right there. And you recognize that that's a negative 2x and that's a positive 2x, so they cancel. So all I'm left with here is just a positive 2. All I'm left with here is a positive 2. And that's all over x plus 1 all squared. So this is it. 2 over x plus 1 all squared. And that's what it is. All right. There are other things that I can show you, but as we go through the questions and they come out, I will talk to you more about those. I really need to move into the reason for which we are here gathered. I really need to move into the reason for which we are here gathered.
Sir,
And yes, please.
It's just a side note. You can clean up Edicus off for me, sir. May I look for 60 assessments, may I see, and it just look messy and I can't keep track with that.
No, man, it's not 60 assessments, man.
I know, it has the expired ones and everything in it. It just look messy. I will share my screen at the end and you will see what I'm talking about.
All right, then, no problem. I will. All right. You know what? I'm not going to do that. All right, I'm not going to do that. I'm not going to do that. All right, I'm going to the syllabus as I speak with you, and I'm being a little purposeful in what it is that I'm doing. I'm going to skip some stuff. Not that I'm not going to do them, but let me just get some of these almost big guys out of the way. So let me look at some asymptotes. All right, let me tell you, I am signed because I'm very cognizant of the time that I have. You know what I'm going to do? Seeing as I just finished a differentiation revision with you, I'm just going to start off with Newton-Raphson. I'm going to start off with Newton-Raphson, and then sort of work my way into looking at stuff. I'm going to do some Newton-Raphson. I'm trying to create a level of madness to what it is that I'm doing. So let me get this out of the way. I'm going to stop sharing here and share another screen. And I want you to just work with me. I think if I do this, it will make more bring that to me. All right, so I'm sharing a new screen.
Sir, more of a conversation with you about the amount of assessments or I get from Edicus off, sir.
It's not a whole lot of assessments. You get about I think you get about what was it? The assessments are reduced. I will tell you what it is. You can after and towards the end I will show you all what the assessment is. It's not a whole lot. All right. So let's just look at the Newton-Raphson. I'm going to try and develop the Newton-Raphson Method now, and to see if we can have this level of conversation. So solving polynomials, polynomial by using approximate or numerical methods, and the Newton-Raphson is one such method that we need to look at. Now, look at the formula. Look at the formula up top. The formula says x to the n plus 1 is going to be equal to x to the n minus f of x to the n over f dash of x to the n. What is f dash of x to the n? F dash of x to the n is the first derivative of the function f of x. So f dash of x is the first derivative. So I hope you know, see why it is that
sir, which dash you are talking about, sir? Point it now.
Let me go to my stuff. That one. You see it? Talk to me now.
Yeah, we see your professor.
All right.
Oh, yeah, you mean the little exclamation, the little apostrophe?
Yeah, man. So it's not just a little apostrophe, you know. Whenever you see that notation, it means that you're finding the first derivative. So if you see f double dash, it means that you're finding the second derivative. If you see f triple dash, you're finding the third derivative.
Yes, sir. Remember that, sir. And then you have to find them. You have to use the one before to find the second.
Absolutely. Very nice. Down. Very nice. So that you remember, it's coming back. Very good. And that's why I decided that I want to start here. I want to start here because I know some areas may be very familiar with you all. So let me start here. I hope this method of my madness works so beautifully. All right. So let me just go to the formula again. The formula says x to the n plus 1 is going to be equal to x to the n minus f of x to the n over f dash of x to the n. What that means? When I find one term, it means that, put it this way. A real life situation. You know, when sometimes when a child goes missing, or you know, there are the people in the States, I don't find that do that a lot here in Jamaica. So that's why I moved up to the States. You know, they are looking for a missing child or a missing animal. You know, say the whole community will come up and come look for one dog lounge, right? In Jamaica, the dog missing, that some people cry, but other section, no one dog. But in a foreign, around with them, policeman are going to sewer main. You understand? Forgot to rescue that cat. All right, I'm not there just yet. Really, I'm not there just yet. One of these days I'll get there. Right? If it's a child, on the other hand, sure. But if you say to me, "But sir, it's a life, and a life is a life," I say, "All right, fine, no problem."
That will never happen.
Trust me. But the point is, if you are in an area of high vegetation, and picture me, you know. So you're it's a wide area. You don't have any helicopter, you know, to come down with no magnifying glass to look above, or no, we call it the little new device they make out, the drones for put up the camera up there so you can see a land and see what going up top. So you have the whole community and everybody can hold hands, right? Because you're canvassing a particular area. So when they canvass a particular area, they're going to put landmarks there to say, we have already covered this area. So let us move to another area until the whole area is canvassed. All right?
Sir.
Yes, sir.
Makaina, get a little thing. Oh, yeah. All right. Let me listen to my madness for a second. Right? A child is missing in a forest, right? The first step in the equation is where the child was last seen.
Very good.
Right. The second derivative is going to, the first derivative is going to be the next point or a estimated point where the child might have been in a specific, another space or time.
Very good.
And then once you're at that point, you can then either start over as that being the equation and then finding another first derivative from that point. That sounds like it makes no sense.
Very good. And you know, ugly for nothing, you know, so that does make a whole lot of sense about it over time. Very
Jesus,
good. So that's exactly the point I'm making. And you get it, right? So you know where the child was last seen. Somebody said, oh no, I was driving on the highway and I saw the child in a red shirt. Yes, the child was wearing a red shirt, and it gives the officers a starting point. So I must have that starting point. And where my starting point is going to be, say for example, in this case, it's going to be my x to the n. That's where my starting point is. And then I know the area. I know the area. There is a slope in the area. So I'm going to differentiate my stuff, and I'm going to substitute some coordinates into whatever it is. And then now I am going to give an estimation where the first point is. Having covered the first point, as Everton says, we know our next starting point. And our next starting point now is to pick up from where we left off. Until we reach a point where there is no difference with this term and the previous term. Once we get some levels of consistency right there, we can say, nah. And you know what families don't want to hear is like when unfortunately that tower in June 28, there about 26, when piece of one building in Florida collapsed. All right, and the officers out there are doing search and rescue, and your loved one is still missing, and I'm hearing them say, well, it's not a search and rescue anymore, it's just a search, because there's nobody that can be rescued at this point. They are believing, unless there's a serious air pocket somewhere and the person still can get little oxygen to live, and that would be a miracle, right? So there comes a point, if one boat capsizes, there's a search and rescue, because them believe so boy, them can float for a little bit and them lungs can take in a little bit. So within 5 minutes, them still can be alive. But after a full day, it is no longer search and rescue, it's now a search. So this is the point I'm making. So when it becomes no longer search and rescue, it means that you've already exhausted what it is that you're supposed to be doing. All right. So watch the screen now. Watch the screen. I have a curve. I have a curve. I have my curve.
Baby, look here. Huh?
My curve. And this curve is this way. So I want to watch what is happening. So look at my spotlight. I have my curve. And my curve is one smooth, nice something. I notice what happened to the curve. The curve went, and it's going, 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 until at one point in time, it crosses this axis called the x-axis. And where it crosses the x-axis, it gives you the exact solution to the question. It gives the exact solution to the question. That's what happens. So let's go again. So I have a curve defined by f of x. F of x is my x-axis, my f of x axis. Here goes my curve. Nice, smooth, sexy looking piece of something. And at some point in time, the curve crosses the x-axis. When it crosses the x-axis, it gives you the exact root of the function. And it continues. So see here, M said this is a graph of f of x. So this means that this graph here, all the way up here, is the graph of f of x. This here is the graph of f of x. See it right here, sir? Yes, sir. Where it crosses it is the exact root. That's my f of x axis. That's my x-axis. All right. So you see those 4 things already. So let us start. I am trying to guess this point, the exact root. I'm trying to guess where this child is lost. I'm trying to guess where this child is lost along this path. Along this path, right? This is my f of x1, my initial guess, my f of x1. The truth of the matter is, not like in a Jamaica, in foreign, it is the norm for people to be their brother's keeper. It is the norm. And you have to, and I know the truth of the matter is, you know, I don't like the place for many reasons, but there are other reasons that, you know, it would be a nice place to live. All right? Because if you send out a broadcast over the airwaves to say, we call it Ananda alert, then call it something else. All right? And it is sent over the airwaves to say a child was just abducted along I-95 in the vicinity of Sunrise and yeah, 95 and Sunrise. People in that area going to say, but no man, I saw the car. I saw that Mitsubishi. I remember because I was driving in front of the Mitsubishi and it did come off at the exit right there. So that person will call and say, no man, I saw the car going west along Sunrise. So when that call comes in, then the police stations know the officers will be notified. So they can converge along the west of Sunrise. And this is where their initial guess is going to be. That's your X1 because they don't know where this missing person is, you know. But then just put out something and somebody in the area who say, yeah man, you see this money? They know where to start because at first the police officers then don't have a clue where this man abducted the picnic and carried the picnic up. Them have an initial guess now. This is your initial guess. Watch me. Then we have them starting point right here. So you see that black dot this? Right here, so them have them starting point. Right this up. When they have the starting point right this up, they are going to draw a tangent to the curve. See? A tangent is a straight line touching only one point on the curve. See right there, so? The point here. That's my initial point. This is the point where the police officers then will start their investigation. So as they exit the highway, the 95, and then reach Sunrise going west, as them go west and them sit in a household, the police them go drive through and said, we're looking for XYZ. Them start right here. So them see here, X1. X1, the x-axis, the first value. Oh yes, so we are start. So then why we couldn't start here? So because around here, so the answer there. So we can't start to the answer. We're too good. It means that there's no investigation. Then, so the answer couldn't be, okay, so sorry, no. But the answer got come where it crosses the x-axis. So we can't start down here, so because the x-axis is down here, so we have to start up here, so. All right? So we start here, so. So this is going to be where my x1 is. So this is my x1 value. What I'm going to do is to say, okay, I'm going to draw me a tangent. I'm drawing me a tangent. A tangent to a curve is that line that touches the curve exactly at that point. So my point x1 is where this tangent here in dotted line is touching the curve exactly at one point. Now you see this line here? This is my vertical line. This is my vertical line that runs parallel to this line, my x-axis. This is my vertical axis. This is my horizontal axis. All right? So these lines, the x1 and the x2 and the x3 and the x4 and so forth and so on, will run parallel to my y-axis or my f of x axis. The y-axis and f of x axis are exactly the same. All right? So when I do that and I draw it and I'm going to extend this tangent until it touches the x-axis. Sir, why? Yeah, man, because our aim is to make sure it cross the x-axis. That's where the exact route is. So everything we do, we need to cross the x-axis. All right? Watch me now. You notice I have this triangle right here, so I calculate the gradient. Remember when every time we talk about mountain Mountain View, Montego Bay, and I drew a right angle triangle, and I say rise over run. This is exactly what I'm talking about. And that's why the Spirit of the Lord said to me, don't do the first part first. Just pick up from where you are and start with Newton-Raphson. Thank you, Lord. See it so? That piece right there, so. Yeah, man. That one triangle. Rise over run. It means I'm finding the rate of change of y, that piece here, so, with respect to x, that piece here, so.
All right, hold on, sir. So the Newton-Raphson only has to do with this triangle. Calculating each stage based on the tangents that are from each derivative coming down.
Excellent. Excellent.
So it's an approximation thing then.
Excellent.
Oh, all right, all right.
So I kind of understand what you said, but I guess when you're doing the actual equation itself, and
Fair
then
enough.
like show where exactly then we might get a better understanding. But I kind of understand ish so far.
Fair enough. Fair enough. And that's why I'm giving you the story behind it, so that when I'm doing it now, the story can make a little bit more sense. You know, Peter Gay. Not to diverge, but you know, sometimes you hear something in social media, but until you get close to somebody who they did it and tell you, it put things into perspective, don't? Yeah. So it we are the writer now. Very
Sir,
nice.
where were you last semester when you were supposed to teaching us? Where were you?
To God be the glory,
Yes,
great things he has
sir.
done. Romain, leave me alone. Romain, don't say nothing to me. Romain, leave me alone.
Where were you, sir?
Oh, hold on. We're gonna have a run-in with Mr. Robinson.
Okay. No, let's go.
Mr. Fast Rubber.
No, so guess what? All right, guess what happened now. So let's continue now. So this is going to be my triangle. So watch this piece up here. So you see that piece here, so? This is going to be my first differential. That's why I have my f dash of x, 1. Remember, no, you know, my f dash of x, so Everton said something, and I said to him, it's the same differential. It's the same differential. It's the same differential we're using. See, just so? This is f dash of x, 1, f dash of x, 2, f dash of x3. So all of them are f dash. So it's the same differential that you're using, because remember one function you're having on. So the one function here, f of x. I know why we can't use different differential. Remember the story is, one little picnic get abducted. You understand? So we know the general area. So you know what happens? This is so ironic, because one summer before COVID, it could be either the summer before COVID or the summer before that. I, could have just shot it from home, and in about 20 minutes, I had a reach an exit. And this day, I never know where I'll keep. And you see, from me, catch up a Ligani, appear traffic. And I'm going to be very frank with you, from about where the Popeyes is and the Texas gas station. No, man, somebody get abducted. In Jamaica, I talk about, and the police, they say the same story I tell about the convergence. They converge and them get a description of the car. And only some cars they were stopping to look into the cars. So you see, from Swallowfield down at the bottom of the mountain view, and appear traffic. It literally took me, I had a 4-hour class from 5 o'clock to 9 o'clock. It literally took me 2 hours plus from stadium to get to Excelsior from college. We're not exaggerating. I was on the phone with my students and said, sir, you can go and talk. Me just reach. And from after 3 o'clock, me I did on my way to exit. So the traffic would have eased up me, you just leave your yard.
I think I remember that day then.
It was rough, Everton. And
remember that day then.
Some people.
How would they tell us I should have drive downtown?
Some people were coming in from different, but they were converging because it was another alert, and they're trying to find this people. So the point I'm making is, they would not have gone to Boulevard, because Boulevard would be at a different grid. They know where this function is. See, so the function is f of x. So that's what's the point I'm making? It's going to be the same derivative, f dash. The only difference now is that we're at different points. So if you look at, I would say, Ligani Road, connects to Mountain View, connects to Donna Rockford side or so, right? I wouldn't say that Barbican Road for argument's sake even connects to it, but sir, it near, yeah, but it not connect because whatever. This is it. At a road that we are use f of x, it now moves, so we can't use a different differential. It has to be the same function that we're differentiating. All right, watch me. So this is my f of x1, and I'm going to get my f dash of x1 right or so. Watch me. You see,
just a quick question. Once you find the differential for where you have the first differential, is that it's going to be continuous throughout the complete equation? It wouldn't change that any at all?
Very good. Excellent, Peter Gay. Oh. The only thing that will change, Peter Gay, is the points that you're going to put into that differential. You follow me? And if you don't,
yes, sir,
right. And if you don't catch fully what I just said a while ago, when I reach there with the question, I'm going to point it out to you. Watch me. So look at this piece here now. So when this thing catch down here, so you remember now, I draw my triangle, and anywhere touch the x-axis, this is going to be my new point. Oh, so this sir they are talk about, yeah man. So the people them search and reach a new point, you know. They reach a new point. So you know what gonna happen? Them gonna have one police guard with some bad dog or stuff right here, so cause them already mark right here, so them search right here. So there's no more searching that going to go on right here, so cause them already cover this piece. So them can put something right there, a security, a soldier man, a military, a zozo. So the zozo getting the right here. So in case the kidnapper want to come back right here, so him going to get caught because them already plan out the part here. So watch me. You see, when we reach at x2, I'm going to draw a vertical line that is parallel to my y-axis. Wherever it cuts the graph f of x, remember now, this is a whole graph of f of x. Wherever it cuts f of x, that's where I'm going to have my second iteration, which is, some people call it the iteration after the first iteration, which will technically be the second iteration, don't it? So my initial guess is my first iteration, right? And then we can have after the first iteration, which is my x2 value, right? So my second iteration here is going to be this point where it touches the curve, but I'm going to be consistent. Math is a study of pattern. There's a lot of consistency in math. So when I catch right at this point here, again, I'm going to draw a tangent to the curve. Remember, a tangent touches just one point on the curve. So when I draw the tangent to the curve, the tangent will cut it and go right down here, so, and we'll cut it at x3. And then this piece here is going to be my x2 value. So this is the differential of my x2 value, right? And then no, we cut x3, press pause. Remember, no, the child is being held in an abandoned building right here, so, right? Or a cave. But the searchers don't know that there is an abandoned building right here, so. But all we know, say, based on the telephone call that came in, the child cannot and the abductor cannot go too far from here, so, because we have police that come from outside here, so a converge come here, so, from here, so. And we who start from here, so. Guess what? I just reach, you know, we cover all of the sections already, you know. We just reach now. So we get closer and closer. So you see what I'm happening? Every time I do my iteration, I'm getting closer and closer to my final value. We reach right at x3 right so now.
The triangle, the surface area, the triangle gets smaller too.
Absolutely. So when we catch up here so now, we reach my second iteration, after the second iteration, which is really my third iteration, my x3 is my third iteration. When I catch my third iteration, I'm going to do the same process as I did in the first and in the second. Wherever it touches the curve, I'm going to draw a tangent to it. And where I draw the tangent, it will catch down here, so. We draw one line parallel to my y-axis or my f of x axis, and I come right as so, right? Now, when I reach right as so now, I can say to myself, say, you know, say, the answer may get right as so, and right as so. And the same answer correct to 1,000th of a place. me now gonna further because at the same result me gonna get. So me gonna stay right there so. I'm gonna use my megaphone. I'm gonna say, this is the police. You are surrounded. Please to surrender. Police don't get no response. This is the police. You are surrounded. Please surrender. And what the police are going to do is use all of them gadgets. Send them dogs, send them this and that until them get the final answer. All right, sir, that was a good story. The end. Watch me now. Watch me. And if you have questions, it's not a problem. Let us just look at some stuff here. So what I'm saying to you, and I'm just going to read it because I prepared a question here already, and the preparation of that question now going to will help you to understand what is happening. I'm saying in numerical analysis, in numerical, and you understand why it's numerical because we're using actual values. In numerical analysis, the Newton-Raphson method, named after Isaac Newton, the very bright boy, and Joseph Raphson, is a root finding algorithm which produce successively better approximation to the root of a real value function. So every time, as I showed you just now in the diagram, every time I perform this operation, I am getting closer and closer to my root. Now let me just pause and say something. If me said to you, say, me call in and say, I am on I-95 and I see the description of the vehicle, just exit on Sunrise. But you now listen to me well and you decide to go Atlantic. It means that you're going to be off trail. You're going to be off the course. But if you go there, you will eventually find the person, but it's going to take a longer time. Right? So what you're trying to do is to make sure that your starting point is as close to your exact value so that you don't digress too far because time saves. All right? So watch me now. It uses the idea that a continuous and differentiable function can be approximated by a straight line tangent to it. No, the function must be continuous and differentiable. Sir, why? Is the function continuous? Look at me if you see any break in this function. Any break in this function? Say yes or no.
Hello? No, I'm not.
There's no break. There's no break in the function. That means the function is continuous, right? That's what it means by continuous, right? If the function was discontinuous, it means it would have come right or so, and then there's a break in the graph, and it would have go somewhere else. But it's a continuous function, right? In addition to that, the function has to be differentiable. Because if the function is not differentiable, what's the formula? The formula says f dash of x. So if the function is not differentiable, I couldn't use this formula because it can't work. So it means that the function that they give you is a function that can be differentiated. If the function can be differentiated, it's a known question. The question can't work, or the situation cannot be solved. All right? So it must be a continuous and differentiable function. Sir, why put that in yellow? And why are you talking so much about it? Because sometimes on the multiple choice, they may say to you, for Newton-Raphson, the following, all of the following is true.
Or false.
Or false. You see what I'm saying? And then you say, one, the function must be continuous. Yeah, we know that because already said. And two, the function must be differentiable. And you may have something about discontinuous. Sir, if function can be discontinuous, right? So you have to know that when you use the Newton-Raphson, is that two conditions must hold. That you have a continuous function and that the function is differentiable. All right? All right, let's go. And it can be approximated by a straight line tangents to it. And you see that how many tangents we would have drawn. All right? Okay, this is it now. Peter again, you asked for it. So this is it. We're going to look at an example. And I want you to work with me. You don't need to write because I've already done this one for you. So I can send this one to you so you don't have to write. I just want you to just pay me attention. Just pay me some attention right here. All right? So this is a function. That's a function. That's what we're looking at. This is where the mystery begins. All right, that's where the mystery begins. Okay, sir. I see, sir, that you are looking at f of 0. Why, sir? Miss won't tell you. And then we see look at f of 1. Why, sir? I soon tell you. But just work with me for now.
Starting point now.
F of 0 is anywhere in the function I see of f of x, I see x, I'm putting 0. F of 0 means anywhere in the function f of x, I see x, I'm going to put 0. So watch me. 0 cubed minus 4 times 0 squared plus 1. Data 0, data 0. So f of 0 going to be equals to 1. F of 0 going to be equals to 1. Then I jump to f of 1. F of 1. F of 1 is anywhere in the function f of x, I see x, I put 1. Let me say it again. Anywhere in the function f of 1 is anywhere in the function f of x, I see x, I'm going to put 1. So see f of x here, so it will come 1 cubed minus 4 times 1 squared plus 1. 1 cubed is 1, 1 squared is 1, 1 times negative 4 is negative 4, 1 minus 4 is minus 3 plus 1 is minus 2. Okay, sir. But tell me why you just decide to just use 0 and 1. You see, because I know, say, Newton-Raphson say, my exact value is going to be found when I cross over the x-axis. I will always try to put in when let's see this crossover. Look here now. You see this crossover? Over here, so a plus, 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 plus. All of this, see here, f of x, all of this black line here, all of this black line here is my graph of f of x. Watch me. All of this is my graph of f of x. But watch me. You see from up here, so come down, positive f of x, 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 positive f of x. F of x equals to 0. Negative f of x, negative f of x, negative f of x. You agree? So down here says negative f of x?
Sir, so in essence, what you're saying, right? Because you're working with Newton-Raphson deals with a graph in its essence, right? The 0 would represent the x-axis, because the x-axis coordinate for the x-axis is 0.
No, correction. The 0, okay, so.
Sir, before I go any further, 0 would be the starting point where up by where you saw, and like scroll down, sir. Oh no, scroll up where the graph is. So the 0 would be at the top there where you have the up here, sir.
Right here,
where
sir?
you have the f of x. No, sir. Up
Initial,
here, sir?
The initial get.
Up here, sir?
Yeah, at that point would be the 0.
No.
The starting point.
No.
And I just say I lost me now.
All right. Okay. All right. And let me go through this, because I mean it's right in front of your eyes, but you're just not seeing it. And that's why I said not you. And then Peter Gates coming.
Oh, my just see it, sir.
Look here. You notice that that this x can be 0 because look how far x there. Look where 0 there. Is there 0 there?
So I just see it a while ago.
All right.
Yeah.
Okay. So you listen to answer on a question. All right.
Yeah. But then may I say equate it to a graph.
No worry about it. I have another story to give you. So you notice what I just did a while ago is to point out what I just did a while ago is to point out what I just did a while ago is to point out the pair of you just now pretty much asking me if the 0 there is my initial value, and I'm showing you where 0 is. So right at this point, this cross here is right there. So where my spotlight is where x equals 0 and y equals 0. All right. So 0 couldn't be here. So this is just my initial value. My initial value is not 0. Initial value here is not 0. My 0 is right here. What I'm saying to you is, the point I'm making is, I am trying to find values of x that shows me where there is a change in f of x. Watch me. Let me just bring across that point.
Oh, you mean say from positive to negative?
Very good.
Very
good. So it's not.
So you have positive 1 and then a negative 2. So that means at that point it make the transition there.
And guess what? And I know that my answer is going to be between right here. So because this is true, we know say f of x is positive, which is above the graph, and then f of x come negative beneath the graph, we know say my answer lies somewhere inside right here.
And that is why you would stop and use a loudspeaker. That's okay, you know them.
Absolutely. There you go. Thank you, Jesus. That's the point I'm making.
Get you.
So because my cross is something now, me know say me over positive, and then now me reach negative, but me know say my exact value is where the curve hits the x-axis. After it hits the x-axis, then it's going at the negative region. So if they are positive and then I go on negative, it means that my answer there in between the positive and negative. Talk truth.
True.
All right, press pause. I would have said a mouthful. Are you following what it is that I'm saying, guys? Make sense. Me alone in a Saturday morning, enjoy myself.
Sir, scroll back up again. Look on something on your graph, sir.
We really want the rest of you to talk to me and let me know if you really follow what going on.
All right, stop, sir. Stop.
Sir, once one person gets it, everybody gets it because we're going to work together because everybody won't pass it. So once one person get it, other person can explain.
All right, so we get it. But let me just
all right, sir, look at this now. So where it said after the third
iteration,
right? Once you hit that point, right? The last I noticed that in the formula says dot, right? That means and so on. So what we're really looking for is this the exact root point, and then the exact point is then not always showing in the entire calculation when you hit that point, but then once you see your answer transition from a positive to a negative, you find that between those 2 points, between 0 and 1 is where, between 0 and 4, this would say 4, 1, 2, 3, 4. Yeah, between 0 and 1 is where you have hit it. So then there's another part of it now that we'll have to find out the exact point, or you leave it there.
All right, watch me. So you just said something that I want to go back to now. Watch me now. So you said that you will see that between 0 and 1, sir, with 0 and 1, that's 0 yes so, and the 1 yes so, tells me that I cross over my axis here, f of x will be equals to 1 and negative and a positive value and a negative value. So it says that you will see that between 0 and 1, the function would have crossed the x-axis. Why? The value of the function has changed from 1 to -2. So guess what? No. We know when you are working.
Sir, I have a question.
Go ahead, Chance.
Sir, the one that you get when you substitute with the x for 0 is the same one that you put at.
You start back from, it look like.
Yeah.
No, is it this one you're talking about?
Yes, sir.
No, not the same one. Let me
So if we got a different answer, we would still put 1 down here.
Let me fix it. And that's a good observation, because I want you to.
Because that's what I was thinking, I was thinking that from one point, we would then start from another point. So it would be the first, I don't know if I'm going to say this right, is based on the first derivative, you're going to use the first derivative. In order to find the second derivative, you have to start from the first to find the second.
Yeah. That is true. So it's a continuous thing. You're using one to do the other. So they don't work in isolation.
So why wouldn't we be using that one, sir?
I'm going to show you, because you see, even though it looks like the same one, it's a different one. All right, watch me now. Watch me now, Shams. You see the one here, so? In a pink, it's different from the one you saw in a blue. This is, mathematics. This is the independent variable, and this one here is going to be dependent, right? This is my y value 1, this is my x value 1. So there are two different ones. This is my, put it this way, Shanice. I have $1 and £1. Both of them are ones. Are they the same? Sir, I can't tell you because they are different currencies and I have to bring them to a common unit in order for me to work out the difference. So there are two different ones. One is my dependent variable. So what do you mean by dependent variable? It depends on the number that I put into the function to get the result. So this one was as a result of putting in 0 into the function. This one is what I am putting into the function. So this one here is a dependent variable. This one depended upon this 0. This one in pink depended on the one in 0. Depended on my 0. But this one is not depending on a soul. This is independent. This is you saying to your peeps, hey, me work my money, you know. And today me driving go down to Ocho Rios. We go a half moon, not half moon, but you know the one, the old time hotel change the new one. You have to go to, you work your money, so you have to go there. So this is independent. Now this -2 is dependent upon this one. So this one in pink is different from this one in blue. This one in blue here is an independent variable, and this one in pink is a dependent variable. This one depends on this 0, but this one is what I'm putting into the function. All right, so there are two different ones. So when I say to you,
so is it a case where we could have put another number then?
You could put another number, no. But remember the point I was saying to you that when you put another number in there, no, it's like you will start from Boulevard instead of getting closer to Mountain View. And Boulevard it's going to take longer.
Yeah.
It's going to take longer. That's the point I'm making. So I try to go as close to what it is that I know. I get the information so I can do the stuff. So this is what I'm saying to you now. So really, my interval now is going to be between 0 and 1. My interval is going to be using 0 and 1. So I'm going to use my x1, my initial iteration, to be 0.5. You remember the initial iteration is my first one. My initial iteration is my first guess, see here? The initial iteration is right here, so x1, all right? So I'm going to use that. Sir, why just use 0.5? They're going to use 0.1. 0.1 is going to be too far because remember, you know, my iteration is going to be between 0 and 1. So you will see that between 0 and 1, the function will have crossed the x-axis. So I am interested in using the 0, in using that 0 and that 1.
Sir, so why you never use 0.25?
All right. So again, it comes back to the point of being at Boulevard as opposed to get closer to Mountain View. So what we normally do, So what we normally do is to say we add the lower limit to the upper limit and divide it by 2. We normally find the halfway point, and the halfway point will tell us exactly what it is. So this is 0 plus 1 is 1 divided by 2 is 0.5, and that's how we get the 0.5.
It was like 213. You that's a 2.5, sir.
You know, say you must eat more breakfast on Saturday morning. Very nice, Romain. Very nice.
Sir, that not go on yet, you know, sir.
It'll come back.
It'll come back. Very nice. Yeah. So that's exactly why we use the point. Yeah.
Sir, right now, I can tell some brain has start slow. It has start.
Well, come here for then. Come, I don't want it. I don't want it now. Come here, you're going well, man. You ask some very nice questions. All right, let's go. So that's why we use the 0.5. It's the midway point between
So we calculate the midway by using the 2 points and then dividing them by 2 then. Correct?
Very good, very good. So we get the 0.5. So it says, please know that we are guessing x1 to be 0.5. It's a guess, you know, because if it's too far off, when we do the calculation, it will show us. But we are taking a guess. So we're starting halfway because we don't know exactly where. So we're starting. Remember, you know, it's an approximation. Yes, Romain.
All right, in the function right there, we have where you see 4x squared plus 5. How did they get the 5? Didn't see that part.
Oh, yeah. Okay.
5, the plus 5 right here.
Yeah, that plus
Yeah.
5 is sir.
How exactly did they get that 5?
It's not supposed to be plus 5.
Sir, we are do, sir.
It's not me. It's type, you know. It's type
I'm
me type.
trying to figure out the way come.
No man, no, it's supposed to be a plus 1. It's type me type. And
Oh,
one or plus 1, I look at the question. It's type me type here, so and that's why we'll go through the stuff. So it means that you're awake. I'm actually proud of you. It's type me type, and it was just a slip of the hand.
okay.
And incidentally, I will kind of just put it right here to make sure that you're really following. All right, very nice. So it's supposed to be actually a plus 1. Thank you, sir.
Yeah.
Okay, so let's go now. So it says, please know that we are guessing x1 or initial guess to be 0.5. All right. In other questions, they would tell you what to use as your x1 value. Just remember that. In other questions, they would tell you. But in this case, they didn't tell us, so we had to go and find something to guess. But in other questions, and I'll show you other questions where they tell you where to start. All right. Like what Romain said, they would say between 2 and 3. So you know, go start with 2.5. All right. Don't start at 2, not start at 3. Right. Okay, let's go. So remember the formula: x subscript subscript, yeah, n plus 1 is going to be equals to x to the n, the one before, minus f of x to the n over f dash of x to the n. All right, watch me. What does all of that mean, sir? This is what it means. So I have my first iteration, and the subscript will tell you what number iteration you're at. So you remember they said that this is the initial guess, and then in the diagram that I gave you, they said that this is the first after the initial one. Let me just show you what we're talking about. It says after the first iteration, you may have x2. After the first iteration, it means at the second iteration, right? So I'm not going to use, this is not my piece of work. All I did here was copy this piece. This piece of work here is just me explaining fully what this thing is here saying. Because if I were doing it myself, I would have called this the first iteration, I'd have called this the second iteration, I'd have called this the third iteration, which in fact it is, because it says after the second iteration, then we have the third iteration, don't it?
Yes, sir.
Right, yeah. Right. So it's just how they put the stuff, right? But anyway, let's go. So now this is what I'm gonna do. So since I already have the first iteration, in order to find the second iteration, I'm gonna have x2 is equals to x1. See here? So you remember, you know, the formula says once we have the first iteration, we're going to substitute into this formula here. So the second iteration is going to be given by x2, since we have x1 already. The second iteration is going to be by x2, and then I'm going to have equals to x1. So it's the x1 iteration, which is a 0.5, we're going to have right there, so minus anywhere in a function where them give me, I'm going to put 0.5, and then we're going to find the differential, and then put 0.5 inside there. Work with me. So I am just substituting here to show you exactly what we're doing this stuff, right? So my x2 is going to be my 0.5, which is my first iteration. And that first iteration, I'm going to substitute it into the original function divided by the differential. Then I substitute in the differential of the function. So see the function here, the function was 4x cubed minus all right, so I'm recording it for you right here so you can see what is happening here. So recall, this is a function f of x. So to find f of 0.5, it's going to be anywhere in f of x, I see x, I'm going to put 0.5. So it's going to be 0.5 x cubed minus 4 times 0.5 squared, see it yourself, plus 1. And it, oh, incidentally, we need a calculator here. I want you to get a calculator now, so I give you a minute to find a calculator, because you have to know be very versed in putting this in the calculator. A calculator on the computer won't help you, and a calculator on the phone definitely won't help you. You need to know how to manipulate your actual calculator in order to get this, because it's a miss or slip thing here. So it's either you get it or you don't get it. There's no in between. Black or white, no gray. All right. So now I am substituting all of that into this function, and I'm going to get out 0.125. When I substitute all of this, I am going to get out 0.125.
All right, sir.
Mm-hmm.
All right. So the formula that you have in purpose, right there, above right there, right?
Mm-hmm.
Well, it's the same thing, but what is different between them, sir? Between it and the second iteration?
Oh, there's no difference right there, so I'm just substituting the values now into the function.
Oh, all right. I kind of did a dwell upon that and kind of miss. All right, continue, sir.
So what I'm doing here, that here is my original function that was given. My original function that was given. And my original function that was given. All I'm doing is substituting my first iteration into the original function given. That's all I'm doing, substituting the iteration into the function given. And then you'll see my function here. F of x is equal to x cubed minus 4x squared plus 1. Then I'm going to differentiate that function. I'm differentiating that function. When I differentiate that function, I'm going to get 3x squared minus 8x. See it right here, so f dash of x is equal to 3x squared minus 8x. Now, anywhere in the first derivative, f dash of x, I see x, I'm going to put in 0.5. So it's going to be 3 times 0.5 squares, see it right here, so minus 8 times 0.5, see it right here, so I'm going to put all of this into the calculator. Guys, remember, I went and did my calculation. I want to double check to see that I'm correct. When I do all my calculation here, what I got to 2 decimal places in this particular case is negative 3.25. Is negative.
Sir, somebody need to plug this in on my calculator right now.
Absolutely.
All right, give me a minute, sir.
And while he does that, for the rest of you who may have already completed it, you remember our second iteration formula right here, so where I said to you that x is going to be equal to 0.5 with all of this. You're now going to tell me what this f of 0.5 is. Remember, f of 0.5 is now 1.125. And f dash of 0.5 is negative 3.25. So I'm putting all of that into my x2 formula, and I'm going to get to 0.5385. That's what I'm getting out. And this here is going to be my x2 value. This here is going to be my x2 value. So if you look at my x1, remember your x1 was 0.5, and your x2 now is going to be 0.5385. So it means then that you're going in the right direction. It means then that you're going in the right direction.
Sir, repeat what you just said a while ago, but just punch it in and get the negative 3.25.
3.25. Okay. So all I'm doing now is, remember here, right up here, so what I said to you right up here is that this is my formula. Remember, we have the formula up here, so and then this is what I'm going to have the formula work out to be now. So my x2 is going to be, we are going to have my second iteration is going to be where I have my first iteration, which is 0.5, minus my first iteration substituted into the original function, divided by the first iteration substituted in my first differential.
Oh God, my loss.
No, you can't be, because it's
maybe how you say it.
Look at this. Look at that. That's what I'm doing.
Oh, okay. So the first one divided by the second,
the differential of the first one, right? So anywhere in the function I see x, I am going to substitute my iteration, my values, right?
All right.
So it is nothing different from what it is that we have been doing, and you have been following based on the questions that you are asking. So I know that you're seeing it. All right. So guess what now? So watch me. My second iteration. All of you watch me. No writing. Watch me. My second iteration is given by x2 is equal to x1 minus f of x1 over f dash of x1. Watch that's my second iteration, You know the first iteration is x1, which is my initial guess.
Yeah.
So
that was given.
Well, It's either given or you work it out like we did a while ago, right? But for the second iteration now, it's going to be x1 is equals to f of x1 over f dash of x1. Watch me now. The third iteration is going to be x3. You see the second iteration is x2. The third iteration is x3. And then now, it is going to be equal to x2 minus f of x2 over f dash of x2. Watch me. You see this is x2? It means it's going to be one less we are putting. Watch here. If this is x2, that means the second iteration is where you put in the first iteration value inside of this. The third iteration is where you put in the second iteration value. So what may I say? The first iteration, when I guess, which was 0.5, it may put in a this. See it right here, so it will put in a this. When we put it in a this and get the answer there, so it's going to be the x2 value. So we're going to put that x2 value now in a this. Not the 0.5 anymore, but the 0.5385. Because we get new information and we work on the new information when we get. Remember, we're still on our solving team, So see it here, so x3 now is going to be different from x2, because remember x2 was going to be equals to 0.5, which is my x1. But my x3 now is going to be my x2 iterated value. See here? My x2 now works out to be 0.5385. So that's a new value that I'm going to be working out with. Sir, is the same thing we're going to do? This is how the topic becomes boring now. The exciting part of it just left. Because all you're doing is the same thing over and over. In the original function of f of x, anywhere in f of x you see x, you're not going to put 0.5 anymore. You're not going to put 0.5385. See it here? Now put 0.5385 into the 4x squared. I think I had copied it before. So let me just go ahead and just paste. Yes. And let me just call it RBCALL. So recall. So what I'm doing here is, now that I have calculated my second iteration, I am now going to substitute that second iteration into the original function. See here? Anywhere in the original function I see x, I am going to put my second iterated value, which is 0.5385. See here, so? So 0.5385 cubed minus 4 times 0.5385 squared plus 1. And then I'm going to get this as my output, 0.003774. Now watch me. The first derivative, and I should do this too, because I really want to get it, guys. I really want to get it. So I'm going to press copy. And then I'm going to press right here. So since I had it right there, third iterated value, recall that and this. So I'm going to recall the two of them. All right? So anywhere in the first derivative, remember, Peter Gay, I did say that I was going to come back to your honey bunches. You see me, I said no, at the same differential me I use. Me nah differentiate it another time. At the same differential me I use.
I would understand, but what I would recommend is that, like, since that you did this already, I would like you to like go through one where you write, and while you're writing, you're talking. I guess maybe I'll understand it much more better then, because I kind of get it now, but the information kind of shamble.
No problem. Right? So the point is, as I was explaining to you earlier, is the same f of x curve I'm using. I'm not using another f of x curve. If I was using a different f of x curve, it means that my differential will be different. But the mere fact that I'm using the same f of x curve, the differential is going to be the same every single time. So guess what? Make sure that your first differential is right at the first go, because you're going to have this incorrect differential I use all the time. So once you make sure that the differential I use are the same right across, you're good to go. You're good to go. You're good to go. All right?
Is that the end of the question, sir?
No! Me only take a little break so I can swallow my saliva and for you to think.
All right, yeah. Give me about another 30 seconds or so.
Yeah, man.
I kind of soak in this. Sir, scroll back up a little bit, sir.
Not a problem. Yeah.
All right. So once we do the differential up further. We do the up further. Yeah. And then we do the calculation there. We just continue by plugging the calculations into all iterations that come after.
There you go. Oopsie daisy, sorry. Yeah, there you go. All right. Let's see if we can finish off this one, and then I can give you one to do on your own in class before we finish. Because yes, you're getting one to do in class. So I
Sir,
can
you
work
forgot,
through with it.
sir. You got literally do one and make me see right away
Yeah.
while you do it. Yeah, man, that one, man.
Romain, I trouble them.
Yeah, man, that me one, sir.
Romain, I trouble them.
Sir, you know, no choice, sir.
I trouble them, Romain. No,
persons do get it, but we don't get it clearly.
Yeah.
Okay.
Yeah, we
But
want
if
to see
you do
you do
one
it.
and then you talk, then we will get it then.
Where's the Romain?
We want to make you say right down in us, so come run through it, man.
Oh, so me think it up on my side. Lord, what on the real gun up on me. It's all right. It's all right. Keep it up. Keep it up. Make sure they get to the A though. All right. Anyway, let's go. So I can do that. So remember now, it's the same function Peter gave that teacher using the same function that the same differential, that is same differential, and of course the same function, right? So once I start off the question, the only thing that will change is my iterated value that I'm going to be substituting differently every time into the said functions, my f of x and my f dash of x. My f of x and f dash of x will never change. Once it is that I will be given the f of x function, and once I find my f dash of x, those are the two functions that I'll use throughout the whole question. The only thing that will change is when I get my iterated values. Now, hold on. So there was a question like this on the exam, and some of my students, when I marked the paper, didn't get the exact value, But guess what? Because some of them, when they did the question, they use either they prematurely round off, but and they got the first part wrong. So because they get the first part wrong, they get the x2 value wrong, and then put in the incorrect value for x2, correctly in the rest of the question. But they have to only penalize them. I think the question was like for 7 marks. So I only penalize them for the incorrect piece there, and then the rest of it now I mark it. So it is important, students. Let me just stop and say that. I don't know who asked me in the group if we have to use EditorSoft. And respectfully, I said, this is what it is that we're offering for the final exam, that is. One of the things I'm going to tell you how it is that I know Mr. Russell does it, because he sends me as a head of department the information. When we ask you to upload your work on the platform, your work is uploaded, and even though EditorSoft may say that you get 20%, for argument's sake for the final assessment, we go ahead and we remark the papers, because you only put in your answer into EditorSoft. EditorSoft does not see the work, but we do. So we remark it, and we say, oh, EditorSoft give the student 0 out of 7 for this, but all right, bam, bam. So I would have had students who put in the incorrect and said, Editor.
Sir, that is a question I want to ask you, sir. Because me know me do some stupidness on the exam there. I sit down and I work out the question them, and my time be up, and I just upload the answers when we get, and never put the answer them in the EditorSoft.
Don't worry about it. That's why I say your paper was marked. So that's the point I'm making. So your paper was marked. So every one of my students, the grades would have gone up based on what it is that you see on Editor. The grades would have gone up. So we remark the papers, and then we update the updated grades to the platform. So which is why it's important, students, very important for you to send your evidence of work. It is also important for when it is that we're going through reaccreditation, because I'm sure this reaccreditation exercise is going to be very unique, because I'm sure UCJ is going to want to see how it is that we conducted our online exams. So they are going to come to me and say, Mr. Shand, we need to get a sample of the scripts for students passing and students failing the course, so we can look through those scripts to see how that. So this is why I impress upon my lecturers, and I would have gotten emails from students who say, sir, I don't think I failed calculus when I want a remark. I said, I have no problem. If I mark your paper and you think that I never mark your paper correctly, I don't feel no way. There's no love lost. There's a channel for you to go through for another lecturer who teaches a course to go and double check the stuff to see if it was remarked, and if you still feel like you were unfairly treated or unfairly marked, you can pay money at this point in time now for a remark. But one of the things I would say to you, like I'm marking my chem papers, and I gave a student 3 out of, I gave a student 3 out of 12, 4 out of 12. I gave a student 4 out of 12. And up to when I went and lie down, I was wondering if the student deserved the 4 out of 12, or I should give the student 3 out of 12. The student got 3 out of 12. Let's check, see if I'm speaking the truth. No, the student got 4 out of 12. And I'm wondering if I was generous and the student should get 3 out of 12. What's the point I'm making? Sometimes when the marking people say, no what, I know say Everton can't explain himself, but based on when I read, I know what Everton has said, so I'm going to give Everton a mark. The person who is getting the second mark in the paper don't know Everton. And when they mark them, say, but this don't make no sense, and take off that 1 mark. So there are times when you're doing a remark of a paper, and you may get 50%, and you just barely get the C minus, and say, no, sir, I'm not 50% me get, we want a remark, and your paper is remark, chances are people can remark and get 48% or 49%. And guess what? Once the paper is remarked, it is the second mark, the final mark of that paper is going to be reused. So then we go on the system, and then we remove that 50% and put that 48%. So I often say to students, a matter of fact, the same student paper I looked at a while ago said that they wanted a course to be remarked. I said, oi, take it from me. If I were you, you passed the course last semester, say hallelujah and move on. All right? So just be careful. So I'm not saying that you're not supposed to go and be, I mean, I've always defended my students' rights. So if you're fully convinced that this is so, go ahead. But just be careful. The grades can go up. Similarly, they can go down. If they go up, whatever grades go up, that's the grade will be used. Whatever grade goes down, that's what they're going to be using. And that way say, oh, sure, let us use that the grade that the teacher gives. Nope. They're going to use the grade that was second marked. So I'm saying to you, be careful. Yes, sir.
Sir, but if you feel already, right? If you take a walk at it, man. If you feel already, you might, just take a chance,
Yeah,
ask
but I mean,
a remark.
I mean, I have no problem with that. I won't even justify that. Let's go. I won't even justify that. It is in your rights, and I always defend my students' rights. If you feel like Mr. Sean never mark your paper right, say, and I won't feel no way about it. I honestly to God won't feel that way. Sir, I don't think you marked my paper right. Can I get a remark? I would say absolutely. I have had to do review of students' paper, and the student was very rude to their lecturer. And they said, Mr. Sean, can you do a review of the paper? And I said, okay, call the student in. And the student sat in beside me. And I said, but brethren, you know, if you differentiate? Yes, sir. I said, differentiate this for me. I said, okay, that's correct. Where you have on the paper? This was a face-to-face exam, the student. I said, where happened? Oh, sir, we make a mistake. I said, okay. So because I make a mistake here now, this is what happened and so forth. And when I went through the paper with the student said, sir, I feel better now. I feel the course with you. When is it being offered again, sir? And there was no love lost, because sometimes, you really don't know. And this is why I keep saying to you, speak to me, because in your headspace, you may think that you know what it is that you're doing. Like what Peter Gay says, sir, we want to work one together, right? Because in our headspace, it's still jumbled. So you have your rights, exercise your rights, but I'm cautioning you. Let's go. So this one here now, my third iteration that I am doing is me putting in the 0.5375. Okay, I did that already, and then I would have gotten out 0.5374. Rockstone. Hold on. But sir, 0.5385, 0.5374. That not close. Talk to me. Is that close?
A bit.
Yes, sir. Then close.
All right. What if we're using 2 decimal places? We reach the answer, don't? Because the 2 decimal place, the one up here, so for 2 decimal place, 0.3585 are going to be 0.354, talk truth.
Yeah.
And the one that will be 0.354 again, 0.54 again, don't?
Yes, sir.
So I'm going to reach my answer. Let me go back to the question and say them set to 2 decimal places. Oh, it never said. But I can stop there, and I'm going to put in all right, it's just an example I'm giving, so I have to put it in. So I can stop the question here by saying to you now for 2 decimal places. So you see, this is what I'm saying here is because the values are so close, there's no need for another iteration. Because right there and then I can put in those 2 values. And look at what it is that I was saying. I put in this value into the function and I get in 0.000. That is 0. Sir, the answer done, the question done. All right? All right. I am going to project this one here. And this one here is 15 marks I'm giving you for this one. Oh, incidentally, the marks for these questions come plenty enough. You hear? Plenty enough. So sometimes you may find it for 15 marks. I mean, I know sometimes when you're doing a paper-based exam, they will give you one for 15 marks. Sometimes they will give you one for 10 marks or them enough marks there. So I want you to write this question down, and then I'm going to stop sharing
Sir,
from there.
Now I write down a question. You have to send the document.
No, but no same. Only want me work through one question.
Yeah, but you're not gonna work it out.
Not gonna work it out.
Yeah, work out this example.
Yeah, man.
All right.
Yeah, man. I want to write down that example. Where I'm drinking the water. I want to write down that example there so we can work it with you now.
We see, we hear you eat all your breakfast now. We don't eat nothing. We hear you eat breakfast.
You can't hear me.
Right now, my blood sugar not low in it. Gone, Right now, my brain start.
You hear me? I drink tea.
We don't want to hear nothing from you.
You hear me? I drink tea. Let's go.
Sir, we are right at the question. Sir.
All right.
X, what a Q.
The rest of you are alive, are awake? I need to hear from you. The rest of you hold stay.
Yeah, I'm okay.
Sure, the second example right up, sir.
Yeah, just right off the second. No, right off the second example for me, and then so you can see the question, so I can work with it. I'm going to do it in class now.
All right, sir.
Cool.
Romain.
Yeah.
This class one Chanel now, because should I understand this real quick.
Yeah, what should I do?
So not sure if she go do it because she don't want next math course already.
Oh, okay.
But I check her.
All right. Tevon, can you unmute for me, please? Davis, please unmute. Anybody know Tevon?
So you're asking if anybody knows Tevon?
Mm-hmm.
Yes, sir.
Yes, sir. No.
Message him and tell him say meet in a class and we want him unmute for me, please. Because if you're not unmute, I can put him in the waiting room.
Come on, give me a second.
Please. Alton Brooks, unmute for me, please. Alton? All right, so for those of you who just coming to me, it's when I call upon you 3 times and ask for you to speak and you don't speak, it means that you're not here and I'm going to put you in the waiting room. If it is that you can't speak, you need to declare it. If you're at work or whatever the situation is. Yes, Palmer, sure. Okay, I just checking the chat, Palmer, so sure. So if it means that I call upon you, you're not doing, I am going to put you in a waiting room. I don't want no spectators in my class.
Sir?
Yes. You know, you're nothing from me again. After you can mute the phone again and just listen to me and say, look how long me I call you.
Pure badness. Pure
Sir,
badness.
I'll be a nice number background, sir.
I don't care. You go to the bathroom, go lock up and answer me and say, yes, sir. Or go to the door.
Sir, that would say, move and answer you.
Come off from my phone. You know, you're nothing from you. I go talk to Miss D and complain to her about you. Right,
Miss D?
Yes. You move jobs?
No, Miss D. But all right, sir.
You know me I talk?
No.
All right, then cool. Out. Yeah, you would talk. All right, Romain, you get through to Devon?
Yes, sir. Yes, sir. Me get through to him.
So you tell him to unmute for me?
Mm-hmm.
Okay. So I'm waiting for him to unmute.
Yes, sir.
Tevon, you're keeping up my class. Tevon, unmute for me, please.
Yes, sir.
You never hear me call the boss?
Yes, sir.
Huh?
Yeah. But
yeah, so,
actually kind of slow, sir. So sometimes.
No, a long time I called for you, Tevon. You have not, I don't know how your voice sounds. You have not said anything to me in class. I don't want any spectators in my class. So I want you to be able to participate in what class, in what it is that we're doing in class. All right, everyone? All right, Papa?
Yes, sir.
All right, thank you, sir. You can mute, sir. That's all I wanted to say to you. All right, that's all. All right, thank you. So utilize the chat like you do now. All right? All right, okay, Shane, I hear you. All right, I just want to make sure that you guys are engaged. I don't want no spectators in my class. I want everybody to learn. All right, so we have half an hour. And I'm going to be changing my screen. Let me stop share here. And we're going to work on share here. And then now.
Sir, you're working on two separate devices?
3 devices I'm plugging in. Something hurt me, see, Brethren? I won't tell you what my light bill look for that. 3 different devices I'm using. Computer, the tablet, and a writing tablet.
No feel no way. You're safe on gas.
Oh no, trust me. We go fill up the other day Everton and a 9,300.
No, sir, not good, sir.
Okay, good.
Right now.
Hold on, sir.
Yes,
sir.
Yes, sir.
Show me the question again, real quick, please.
Hold on. Everton, me say when the man say 9,003, me swallow hard, me gulp. Me say okay.
With fear little vehicle, sir.
With family, no, it's 54. Believe it or not, 54 liters of gas we put in there every time I fill it up, you know. No. See, it's not so little, man. 54 liters.
Big, that means the engine big, but,
all right, sir. All right, sir.
Traffic are killing it.
No. So
a 2 yards for drive on the hill, man. So you live uptown. So you live uptown, sir. Up the hill, you know.
So it's where nigga know your business. No, but it's rough, man. It's a rough period. I didn't to see the back of COVID. We know it's rough, you know.
Sir. Man. So you have invested in the water tank that we spoke about, where you would excavate a small part of the garden where you have out there, where you grow your orchid them, sir, and make like a 10 by 10 room, a 10 by 10 by 10. A 10 by 10 room by 10 foot high, and just turn now a water tank and get a pump.
Long time. I don't have it like that. I use gravity flow that I have.
Oh, so it's above.
It's above. Yes, I have about 4 and 4, 8, 9, 10. I have about 1 gallons of water stored. So where I live, I have water problem, but I can't tell the bill now. So I turn on my tap and don't get any water here because I double the storage capacity. So I'm not even worried about that, but it's just that it's a rough period, and I really want to see you guys through this period so they can finish off on the stuff and then they can earn a money or two. All right, let's go. All right, so this one here, let me just write the question here. All right, let me see if I can turn this. Lord, I pray that this thing just write properly now. So I have, it says, given the equation x cubed is equals to 2 minus 2x. show that equation has a root in the interval 0,
So x cube or x squared?
X cube equals 2 minus 2x. X cube equals 2 minus 2x. X cube equals 2 minus 2x. Before I go further, let me just say something. I don't know, for those of you who I have taught before, knows me, for those of you who are coming over to me for the first time, I don't want to use anybody's fat to fry me. You may not be able to speak in somebody's class. I don't care about that. When you come in my classroom environment is different. It's much lighter, and I create an environment where I want my students to feel like they can talk to me and ask me questions. So I create a light environment. So I don't want anybody to shut down on me. Please. Please don't. All right, let's go. So given the equation x cubed equals that, show that equation has a root in the interval 0, 1. Hence, find the root to 2 decimal places. Oh, that's already a while ago, you know. So we could have stopped at the first example because, you know, them could have told us to stop at 2 decimal places and then the answer would be 0.54. Since one was 0.538.
Stop talking to yourself and work it out, sir. Work
see,
out the sum.
No, I want you to listen to what I'm saying. Romain, you understand what I'm just saying a while ago, don't?
Sorry,
Sir,
you know,
I'm not
some step where? When you go for a rubber, sir. What you say?
All right. No, I was saying something because I was talking to you about it, so that's why I was repeating myself.
Okay.
I was saying that this question says to 2 decimal places, and then I'm saying it's like the same question that we just did because of the third iteration or the second iteration was 0.538,
yeah,
and then the third iteration was 0.537. But remember, I was saying to you that both of them could be the same answer if the question had set to 2 decimal places.
Yeah.
All right. So this is what it is now. Right. So this is what it is that I'm doing now because this one says to 2 decimal places. So that's why I was repeating myself and then Everton cut our story short. But anyhow, so that's what it is that I was doing just now with you to show you that
make it work easy. Yeah.
Right. So it is saying to you So it is saying to you now that it is 2 decimal places that they want, right? So it is going to be a little bit easier for us. All right. So
yes, sir.
Yeah. So if it says now x cubed equals 2 minus 2x, all right, sir. You never see it like that, you know. Me see normally to have like one equation, so you go write this as x cubed plus 2x minus 2 equals 0. Yes, sir. So at least you get the equation now. Sorry. Now plus 2x. All right. So now I have that. So I am now going to let my f of x to be equal to this function, and the function is going to be x cubed. So while it's in f of x equals that, because remember say the function talk about f of something and f of something. So instead of put y, let's go put f of x. So again, that f of x equals all of that. All right. So that's what my f of x is going to be equals to now. So right off the bat, I'm going to say therefore my f dash of x, because I know I'm going to need the derivative, so let me just get the derivative out of the way now. So even for that alone, we can do, we know we're going to get a mark. All right? So differentiate that for me and tell me what to get.
(3x squared plus 2).
Very nice. 3x squared plus 2. Who was that a while ago?
Sir?
Who was that a while ago? That wasn't Romeo, no. Who was that?
Parchment, sir.
Oh, very nice, Parchment. Very nice. Thanks for participating. Very nice. All right. So it's going to be 3x squared plus 2. All right. So now I have my differential. I have my differential. No. Jeez.
Sir, hold on, sir. My internet just go out just a minute a while ago. A few seconds. Let me say I have let f of x equal x squared plus
x cubed.
How do you want to say x squared?
So based on how them give you the question, I was going to set it as equals 0. My equation equals to 0. So I was transposing or rearranging, so to speak. It's rearranging. Yeah, that's the word. So I'm rearranging the equation. Remember, they gave me as x cubed equals 2 minus 2x?
Yes, sir.
Good. So I am rearranging it. So in rearranging it now, I just put it as x cubed plus 2x minus 2 equals 0. Talk to me. You see?
Sir, I understand.
Okay, good. All right, good. All right, so let's continue now. Very nice. Love when my students follow me. All right, let's go. So now I have my f that where I was actually was to ask you now, what is going to be my x1? What do I use my x1 to be?
All right, so sir, before I go any further, so the F1, the equation is basically when you differentiate the equation, right?
Very good.
Mm-hmm. So I'm just write it along. So once I go back, we can just get it.
What do I use for F1? Sorry, x1. What do I use for x1?
Sorry, man, I don't know.
Hold on, sir. So x1, x1, x1. So that means you're going to use back the answer that you got.
X1 is my first iteration. You have the interval. What do I use for x1? Come on, I told you this. We had a conversation about this just now.
X1 you use back
0.5.
Thank you. Duh. 0.5. Tell me how she get 0.5. Come on.
Because you know the 2 points are between 1, so you divide them. You add them and divide them.
Yeah, man. Same way, so. Same way, so. Come on, man. We can do this, man.
No, sir.
Very good. Someone wants to
you getting 0.5?
The 0.5, we look at the first, or between, the interval is 0 and 1, Candice?
Yes, sir.
Right. So what we do now is we find the midpoint. We find the midpoint between the 0 and the 1.
Okay.
So 0 plus 1 are 1, and 1 divided by 2 are half. So that's how we do it.
Okay, sir.
Yeah, man. Very nice. All right. So we get our first iteration. So we know what our first iteration is. All right. So now, x2 is going to be equal to x1 minus f of x1 all over f dash of x1. All right. So we now have our first iteration. Let me pull up for that one. All right. Somebody's microphone.
Sir.
Yes, please.
Sir, are you me?
You man, talk. Go ahead and talk.
All right, sir. Suppose so if you get another question where you don't have any when you have to find the interval, there's like something like the 0.5, sir. So if you have like between 3 and 5, you would add it and then you will divide that by 2.
Very good.
Also to get the answer.
Very good. To get the first iteration.
To get the first iteration.
Yes,
but then it depends on the question. Because if they say this is between 6 and if the graph that they give you or whatever the question says between it is 6 and 5 or 6
and 6. Not 6 and 5, but 5 and 6.
Yeah.
Small first and a big after. Yeah. So you're right, Kimmy. Yeah, but in the first example I gave you, remember they never told us what it was. We had to go and figure it out.
Yeah.
So I'll show you how to figure it out. You substitute values, and once it is that it can cross over, then you know what it is. All right. But once they give you the intervals, and most often than not, they give you the intervals, right? Because they don't want students to sit down and play around and start off down a Ocherius when actually they should have started off in a Kingston, right? So on the exam conditions, they will give you a guide as to where to start. So just find the midpoint. If the midpoint is too far off, it means that when you do your first answer, you're going to get like 0.3 something, and it's going to carry you down to where you're supposed to be.
Okay.
Got me, homie?
Yes, sir.
All right, so let's.
All right. It's going to work out.
It's going to work out, man. So let's go. So having calculated our first iteration, we are going to do the second iteration. Okay, so what I write down, x2 is going to be equal to x1 minus f of x1 over f dash of x1. So like I said fast, but You see the formula already. So I'm going to substitute this into the something now to say my f, let me put it over here. Let me put it in a different color so it kind of just looks nice-ish. So f of 0.5, f of 0.5, oh, Rockstone. Put it in your calculator now, please. I need to put it in my calculator to make sure that I get the right something. So let me just run for my calculator. You put in 0.5 into the function, please.
What we're supposed to be doing now?
Sir, negative 0.875.
Yeah, that might get to.
You can watch it now. Yeah. Care to I watch me get now.
What do I get for the answer?
Sorry, negative 0.875. That's what I got.
Okay, very good.
And someone else got it as well.
Very good. That's what I get.
Very careful, watch me.
All right, that's what I get. Guys, I really hope you're following, because I can't write all of those substituted values on the stuff, or else I'm going to run out of space, and I want to see if everything can hold on one screen, so at least I have the stuff. So 0.5.
Sir, I'm still try to put it in a Makenko.
So just put open bracket, 0.5, close bracket, all cube, plus 2, open bracket, 0.5, close bracket, minus 2, and it should give you negative 0.875. Chance, you all right?
Sir, I'm gonna get 0.75 for the denominator.
All right, 0.75.
Yes, sir.
Let me just double check mine. It says 0.75.
Yes, sir.
Sir, repeat what someone put in a while ago. Why you say to put cube?
Yeah, because that's the original function.
Oh, so you're going to put, hold on. So the original function over the derivative.
Yeah.
So how the 0.5 reach?
The 0.5 is the first iteration. See, circling yellow, Everton.
No. Oh, okay.
Okay.
Oh, all right, sir.
Me get 2.75.
Yes, sir.
2.75.
Yeah, my figure, my left of the 2.
Okay, all right, 2.75. All right, cool. 2.75. All right. So now that I have those two values, I can go ahead now and put it into the stuff to give me x squared is equals to 0.5 minus negative 0.875
over 2.5.
Not all over, no, it's just 2. Yeah, it says not all over, right? Just remember that the x1 value says that one. Tell me where you get to this now. 0.5 minus, and then we have a negative 0.875, 2.75.
So I'm gonna get 0.81.
Make it 0.8181 down.
Yes, sir.
Yes, please.
What I understand is like we have the f.5 equal the minus 0.87. Sir, oh, you get that?
Anywhere in the original function, I see x, I am putting 0.5.
Come on, just plug it in basically.
That's all we need. We're just substituting. So go ahead and substitute it.
So you get 0.8181, we get 0.81.
Yeah, man, 8.8181. Chance, what you saying?
Sir, I be careless mistake me I make.
All right, never mind. But you figured out the mistakes, though, right?
Yes, sir.
All right, great.
So, sir,
hold on, sir. Oh, you put in your
no,
the
Mama
calculator.
ask, sir, this first. Tell just give me a minute, Mama ask, sir. So, sir, we don't have the x square equal the x. What do you call that?
The first iteration.
The first. Sir, sir, we have the x1, right? The first derivative, but I have 0.5 right there. So, right? I have the x square. Where the x square? No, number x square. X and the second derivative. That's something there.
No, man. Remember, I don't have any second derivative now. The second iteration.
Sir, above that, we have the formula above that.
Right.
Yes, sir. So, sir, we have the x, whatever, the one,
X1.
but I have 0.5 right there.
Very good.
Then minus the x1 will be the equation, which is the 3x squared plus 2. So
no, it will be the x cube. It will be the x cube plus 2x. Is a value for x1 again put in there now. So look here, it's in a function right there. So no, hold on. Is it in a function right there? So
write it out, sir.
No, man.
No, man. Make him tell me so I can understand.
Look here, watch what I'm saying. Look here. You see another f of x here, so you see where you see the spotlight? The one there, we're gonna put in the first iteration value. What's the first iterated value? 0.5.
The 0.5.
Right. So in the equation here, so the x cubed plus 2x minus 2, we're gonna put in 0.5. You want Everton put it in for me.
Right. Why am I feel like my last?
No, you can't.
No, I just tell you how my brain works. Because I need to go down to the last couple minutes. My brain, I just start.
No, last, I skip a step.
Minus.
Don't skip no step. By that time, problem, I love shortcut.
I can't say the shortcut.
Sir, I love shortcut.
Yeah,
and that I keep on tell you.
That's what I mean. So you get the 0.875 right there.
Stop shortcut the thing, sir.
You don't know how to put it in? I mean, you don't know how to substitute?
No.
All right then. Don't say nothing more. Don't say nothing more. All right. So everybody's supposed to be at this stage. Yes, Peter. Yeah, want me? Using a Ken computer again?
See me, I tell you.
No, sir.
Yo, I can't come here use.
That's the problem. That's the problem. Peter, what calculator you using?
Sir, a sharp.
That's the problem.
It's dull. May I use a Casio X82 ES Plus?
All right, that's a good one. All right, go ahead now. What's the question, Peter?
Sure, no.
All right. Everton, what's the question?
Sir, put the mouse put the pointer where you skip the step, which I've explicitly asked you not to.
I have not skipped a step.
Yes, you did. Yes, you did.
What here?
You just wrote the step there that you skipped.
Right there, so?
Yes, that's what you skipped.
I want to put in, forget negative 0.875. So write that in.
Yeah. Oh. See, you skipped the step. Just say you did and apologize. It's easy.
I am sorry. You see? Make sure when you do something, you say apologize. You apologize.
Oh, yeah, but of course. Right. You see, I did not take the lugs off the wheels on your car. You see that?
It's all right. One of them there again by my X9 here.
Could I be an X20? Me just need a lug tool.
So that would be 0.82 then if we would go and buy 2 decimal places.
No. Thanks for reminding me this point, Romain. So what happens now, Romain, is when they ask you to work in 2 decimal places, you're always working more, and then the final answer is what to put into 2 decimal places.
Okay.
So
Cool.
I choose to work in 4 decimal places, so it gives me a better approximation.
Okay.
So my answer comes out to be close to theirs. Right, guys? So always use this as a tool, guys. When they say to work in 2 decimal places, don't work in exactly 2. Work in 3 or 4 decimal places, and then you put your final answer in the required number of decimal places.
Answer for 3. If you're asking for 2,
you could work in 3 now. That's what I'm saying. You could work in 3, but I prefer to work in 1 more than that, so that my answer comes out to be very close to theirs. very close to theirs. But yes, you can. All right, let's go. Can I move now, Everton?
All right, Mama tell you, I kind of getting a feel toughish right now. But anyways, so is it a case whereby when I get the 0.87, it just substitute in the first equation, which is the x3 plus 2x minus 2 add, sir, let's say plug in the information, sir. Forget this. But when I get mixed up, sir, I will have the x.
Take your time, take your time, take your time, take your time.
So I think when we get mixed up is that where the formula is, or you have the x1 minus the f and the first what do you call that?
Iteration.
First iteration over whatever the. Sir, you know me I talk right. So
Peter Gay, stop.
That's how we get mixed up.
Watch this. Look at me. Look at me. Look at me. What I'm saying to you is having calculated my first iteration, whether or not it's a guess, an initial guess, and guess what? Your first iteration is going to be an initial guess because you don't have any information.
Yes,
when I guess my first iteration, see here, 0.5.
Sir, but I understand until understand when you reach right there, so but like after
so
that, when
we reach right there, I'll come in, Everton. Hold on. When we reach right there, so all I'm doing is substituting that 0.5 into my f of x, and then I will get this.
F of x, which is the first equation up here, so sir.
The original equation. F of x, the original one.
Oh.
And then see here, so anywhere in f of x, I see x of input 0.5. See that so? 0.5 cube 2 plus 2.5 minus 2. All right. So you can write this yourself because we have enough space. That's why I didn't put it there. But watch me now. Look here. Right here. So f dash of 0.5 is going to be 3 times 0.5 squared plus 2. 0.5 squares is 0.25, and 0.25 times 3 is 0.75 plus 2 is 2.75, and that's how I get my 2.75. 2.75. So this 2.75 and that negative 0.875 is right here so and right there so.
All right,
so that's how I get it.
You know, so if you want to know my left out. So you see up on the top where you have let f of x equal the equation, sir. There's some left out, sir. That's why I wonder, say, oh, I get that, I'm going to just realize it while I do it. I'm just right in right now.
Fair enough. All right. Tell me the rest of you now. Can I move? I have to move in a class.
Sir,
all right, cool. All right, let's go. Let's go. So now, I'm going to erase all of this piece here, so because I don't want it, you already see how I get it. So I'm erasing here. All right, so let's go. So having done that, and then putting it into the formula, my x2 formula right here, so I'm going to get my 0.5 minus a negative 0.875 over 2.75 to give me my 0.8181. 0.8181. The question says to 2 decimal places. You are not allowed to work in 2 decimal places. You are allowed to work in 3 or more decimal places, and then your final answer you put to 2 decimal places. That's how the question goes. Now, I chose to work in 4 decimal places. I chose to work in 4 decimal places. Sir, why? It's just my preference. But if you want to work in 3, it's fine, right? But you can't work in 2 because the question says to leave your answer to 2 decimal places. So you have to work in at least 1 more than what is given. All right? So let's go. Let's go. So now that I have my x2 value, look at what I'm going to be writing. Now that I have my x2 value, look at what I'm going to be writing. I'm going to be saying to you now that my x3 is going to be equals to my x2 minus f of x2 over f dash of x2. All right? That's what it's going to be. So just remember, my x3 is going to be equal to f my x2 minus f of x2 over that. So all I'm doing again, guys, all I'm doing is this. Looking for my original function, my f of x, and I'm going to put f of 0.8181. And that's going to be equals to 0.8181 cubed plus 2 times 0.8181 minus 2. And when you do all of that, what do you get?
0.184.
All right, good. That may go right. That's what we get. I will get equals 0.1837. You're not wrong, Romain, but I will use 4
Yeah,
decimal
no,
places.
I'm round it up. That's
Yeah,
fine.
you round it up, right? So that is correct. Very good. So that is that f of x value. Then I'm going to calculate now my f dash of 0.8181. So where's f dash of x? So it's going to be 3 times 0.8181 squared plus 2. Where you get?
4.
4.007.
4, sir.
You get 4.0079. 4.0079. Same difference. All right. Then now I'm going to say x3 is equals to, what was my x2 again? 0.8181 minus 8137, good, over 4.0079. Put that in and tell me where you get out of that.
0.7722.
Very good.
0.7721, sir.
The 0.7723. Same difference. I can't kill you for the 2 and 2 3, right? So that's what I get. But guess what happened now? I still can't do anything with this. You know why? Because it is too far off. Yeah, man, it's too far off.
Another iteration.
I need another iteration. Very good, because look at this now.
Sometimes it is tedious, sir.
It is tedious, but guess what? It's nice.
Sir. Oh, you must say too far off.
Because I'm going to show you.
So too far from the state. That's all.
Yeah, man, because look here, the first iteration was 0.5. Oh, crap. I keep erasing my stuff, guys. I'm going to write it back. My first iteration is 0.5 Everton. Then my second iteration is 0.8181. And then my third iteration is going to be 0.77. So when I round off to 2 decimal places, I'm going to get 0.82 and then 0.78. So it is too far off. There's no consistency right there. So it tells me that no matchup. So it tells me that I have to go on something further.
Pretty close, right? Much, yeah.
Right. So I have to go on to another one. All right.
So what is your end point? What are you trying to get close to?
To find something that matches. I'm trying to find my exact value.
Oh, so the two answers, so two
supposed
answers
to be the
have
same.
to match.
Yeah.
Right.
And you understand why this question now, Romain, is 15 marks?
Yes, sir.
It's a whole heap of work you have to do. Yeah, man. All right, so let's go now. So we're going to have our x. So we have to go to x4 now. So x4 is going to be equals to x3 minus f of x3 over f dash of x3. All right? F dash of x3. Now, all you're going to do is you're finding f of 0.7723 and f dash of 0.7723. So it's going to be 0.7723 cube plus 2 times 0.7723 minus 2, and that equals what?
0.0052.
Sounds like when we get to. 0.00, me get a little bit more than you, 5236. 5236, oh Lord, this pen is gone again. 5, I keep doing that. Point 7.723 and at 0.00523. All right. Let us write a 6. Calculator, give me an extra 6 there. And then no, the f dash of x.
Leave it at the 4.
I could. It's not going to change. Your answer will be the same as my answer now. I promise you. F dash of x now. F dash of x is going to be 3 times 0.7723 squares plus 2, and that is going to give me, what you get?
3.7893.
Very good. 3.
Sir, isn't it supposed to be cube, sir? How you get back a square there, so?
That's the second derivative. That's the first derivative.
Sorry.
7, 8, 9.
So make it basically 3.788 right there.
So that sounds good.
79. Because there's that fruit, you know, spared.
And then no, x4 no. X4 is going to give me, my x3 is going to be 0.7723 minus 0.005236 all over 3.7893, and that gives me what?
0.7709.
All right. Can I finish now?
Yes, sir.
Why?
The two decimal, yeah, the 77.
Very good. So it said to 2 decimal places. Theta, so 0.77 and 0.77. So it's what I'm saying to you now, that working in, them said to use, to do it in 2 decimal places. When you work in 3 or more, it gives you a better approximation. So if them ask me to work in 2 decimal places, I work in about 4. You know why? Because it gives me a better approximation. Them can't ask you to work in 2 decimal places and keep rolling out in 2. You have to work with at least 1 more, right? So, but sir, 0.7723 and 0.7709, that's not the same. You know, the question did say to 2 decimal places. So when I round off to 2 decimal places now, I am getting that as my answer. So guess what?
I'm not telling a lie, sir. My brain reached a point there, sir.
No man, guess what?
No, hold on now. May I try follow or go on to have my follow to a point, and then the rest of it is just blah, blah, blah.
All right.
I understand it now.
Yeah, but guess what now? Your brain reached that point. Your brain reached that point, and we're at that point of the class where it is that it can go cool off, and then take a little break, and then come back and look at that example. Sorry, because the question is actually finished, and so is the class. So what I'm going to say to you is, the question is really not difficult. Let me tell you what becomes difficult. I know Romain gets it, right? What becomes difficult is, all right, I think I'm talking too much. Hold on there. So what becomes difficult is you understanding this in class now, but then don't try to put it to long-term memory. So we'll come to next class, you can forget everything that you would have done.
That's why I give you some. That's why
that's what I'm going to give you. That's what I'm going to give you.
Practice.
Yeah. So this is
but
what I want.
I kind of understand it now, because what I realize, once you miss the first part, then that's where completely hell broke loose. Because what I realized and what I wrote down was that once you put it in an equation form at the top here, and then you send it f of x equal to x squared, and then you differentiate so man, do say it properly. When I differentiate it, I get the F and the thing like the apostrophe at the top, and then once I understand that, and then you know how to put in the information, then you understand. So what I realized while you were going through it, I missed some part at the top of it. Like I missed a little thing there. And so I was having issue understanding how you get the negative 0.87 and the 2.75. And then while they were doing it, that's where I realized where I went wrong. So my understanding now, I just constantly practice it to get it 100%. But sir, what you can do, so the class finish, you can just send it in the WhatsApp group, the stuff, so we can do it. I'm sorry, done.
At x3, right? X3 is equal to 2x minus f of x, the second derivative at the top there. So we have f of x 0.1, 0.81. What them last two digits there in the bracket there is for sir of this? What that look like there?
The 81.
Bracket.
You're just not right it good.
81.
81.
81.
81 what?
81.
81.
Okay, thanks.